change the display on your side so people can see.
Okay, so welcome everybody. This is the November meeting of the Robotic Society of Southern California. My name is Ben Partida. I'm the current president, and we are welcome. We're joined here today by the founder of Petoid, RZ, and he's going to give us a presentation on the history of Petoid, Finland, their products, and all the good stuff. So if anybody has questions, I'm sure he'll be happy to answer. So, RZ?
Can everyone hear me?
Yes.
Yes.
Thank you.
Great. Well, so because it's already 2 a.m. Now, I will try to make everything brief. And I think it will take about 40 to 45 minutes. And after that, we can you can ask some questions. So let's get started. First, a short introduction of myself. My name is Rongjong Li, and when I was in the US, people call me RZ. I've been in the US for 9 years, and for the first 6 years, I've been in Wake Forest University for my physics PhD and computer science master degrees. After that, after my graduation, I just got a chance to touch the Raspberry Pi. Before, I was mostly in theory and doing computational research. But with the Pi, it just makes the bridge between the hardware and the software. And I happened to be a handcrafter when I was a child. In a very short period, I was able to build a prototype of the robot dog and cat. Then I just really got into it and kept researching and developing it for 1 year. Then I decided I can no longer work and doing this hobbyist project. I had to make a decision. So I reached out to see if this project can make any use to other people, to the society. So I released the prototype demo to YouTube. And without any promotion, it just went viral and got a lot of reports. That's how I realized that, well, I can really work on this as my full job. So that's the start of my startup. And now, after that, I went to Pittsburgh and worked full-time to bring the prototype into a mass-producible product. That's the first model, the Nibble cat. Some of you may have already seen that. I chose this design because if I want to go mass production, I didn't have much money. I cannot go injection molding, but the laser cut is a very fast, efficient, and low-cost method to mass produce a whole batch with stable parameters and to keep the price down. And the joints are used for regular hobbyist joints. Servos, it can do the position control. And I developed the working and posturing algorithm all around this low-cost actuator. For the circuit board, I basically jump wired a lot of modules together to make it functional. And later I got a friend who could draw the layouts of PCB and send it to a Chinese factory to produce it. With this everything ready, I think I got a product that can sell. So I went to Indiegogo and launched the campaign for Nibble without any ad budget, of course. I mostly doing the social media posting and was lucky to get some reposts from the KOLs like the Raspberry Pi and Arduino Twitter and so on. And the campaign was successful. I got 140K US dollars raised during that campaign. So that was my initial funding. I didn't get angel investors. I didn't get much personal saving. The largest investment before that was the purchase of my petoid.com domain. it took me $2K when I only have about 8K saving on my personal account. So with that initial funding, I was able to start the small batch production in Pittsburgh. In a factory, I rented a working table. That's all that started. And after half year, I finished shipping the first batch of the product. Then I went back to China because my visa was expiring, and also I found it was difficult and slow to get supply chain delivered to me. After I returned China, I went to Shenzhen and Dongguan. That area was called the capital of the manufacturing in China, where the supply chain is all around the place. I can get the parts within 1 or 2 days after I send the order. I can get the PCB manufactured and delivered to me within 5 days. That is the speed, the so-called Shenzhen speed. So after I returned, I was able to find the supply chain and the factory who were able to handle all the production of the NevoCAD for me. And compared to the previous cost in the US, I saved $50 in BOM. And consider the MSRP of the robot was $225. So just by changing that manufacturing to China, I saved $50. And that also proves I didn't make money from the first round of the product. It was all like, I want to make it, and I didn't consider how to make much money. But after that, I also built a connection with the local manufacturer, made friends with the factory owners, especially the servo manufacturer, who was very willing to support because he believed if my model can be successful, it will promote the servo, the application of servos, because every robot, a walking robot, will have so many joints, and each one can make sales from maybe 10 servos. So he was very supportive, and I got free places, free room, free dorm, and I simply lived in his factory for the following 2 years. And here I learned how to make injection molding. Of course, I don't make it, but how to adjust my design for the injection molding, and also how to collaborate with their factory, because they are very professional and among the top factories who can make customized servos. Yeah, so during this period, I also keep selling the NevoCAD robot, got feedback from our users, so we can think about how to improve it on every aspect. And that thinking, that hard work, resulted in a new product, the Beetle Dog. That's like this. And it has the upgrades in so many parts. The first is the structure. We were able to make a sturdy injection molded structure, and it was much easier to assemble. Previously, the laser cut structures, they are 2D. We cannot build complex structure unless we use the interlocking mechanism, but it's so difficult to assemble. Very few people, very few skilled people can handle it without problem, without too much after-sale support. And then we also customize the servo that meets the special requirement for walking, because servo, they were previously used for controlling the direction of vehicles or planes. So they are mostly directional. They are not expected to apply much force. But for the quadruped walking robot, we not only require the high precision of joint control, but also the servo itself will be used as an actuator to push something, to push the whole system fast. So that puts a high requirement on the accuracy, on the speed, and on the output torque, and also energy efficiency. We were able to configure the best parameters with the factory and also the shape. You may find that the shape of our new servo is slightly different. That's designed for the better appearance because it was used for the joints. And we will also, yeah.
I have one of your servos here. I'm gonna pass it around so that everybody can see it.
Sure.
You guys want
And you can also notice on the NibbleCat, we're still using the traditional shaped servos, square one. And we cut the servo on this edge just to make the servo look smaller. Yeah, that's related to the appearance considerations. We were also able to find the battery manufacturer. Previously, we were using the standard 14500 LiPo batteries, but people get confused and they usually buy the AA battery. And now we were able to get this battery. And I designed the case and got the battery codes to be manufactured and passed a lot of certificates. And this part requires MOQ of 5K units. That means if I want to make this battery customized, I have to put order for more than 500 batteries. That's a lot. Yeah, and that's really a big move. That means we have to decide if the new product can reach that amount of sales. And fortunately, later we reached that goal. And also for the circuit board, previously we designed the circuit board as variants of Arduino Uno board. It uses the chip Itmega 328P. It's a popular chip for the Arduino Uno users. It has so many projects around it, but it has limited resources. To be specific, it has 2K SRAM, 32K flash, and 16 megahertz clock frequency. That's too small and too slow. So we also upgraded the board to the SPI board, and this is based on the ESP32, a popular board that was used for IoT. Usually it's used only for its communication functionality, like Bluetooth and Wi-Fi. But we discovered that it is fast and large enough to hold our dynamic code. So I revised the code to make it more readable and easier to develop by the users themselves, and also improved the connectivity of the board. So this board alone can handle the connection and functionality at the same time. And as a comparison for this first product MyBoard, if we want the wireless connectivity, we will use these dongles. This is a Wi-Fi dongle using the ESP8266 for Wi-Fi, and Bluetooth dongle.
I think we'll be able to see it better if you quit screen sharing while you're showing that.
Okay. Wait,
There you go.
am I sharing my screen? No, I'm not. Okay. That's it. This is the Bluetooth dongle. And this is
RC, I have the first. I have the first version of your Biddle that has all of those things. I'm gonna pass them around so that we can see them here.
Right. And when I was building NeeboCAD, it was all controlled by an infrared remote, a standard infrared remote, car MP3 player remote with 1, 2, 3 and play and stop. And this time we also customize the panel, so it makes more sense, like the up, left, right, down. Yeah. This panel also requires mass production. We require at least 3,000 units to print. But the problem of this infrared remote is it is broadcast. When you press the button, the infrared light just spreads out. Every robot receiving this signal will react. It's actually a convenient and cheap way to achieve the synchronized control, right? But the problem is you cannot achieve one-to-one control. So with the help of this Bluetooth dongle or with this built-in Bluetooth connectivity, we were able to build the Bluetooth connection on a phone. So we designed a smartphone app for both iOS and Android. This app is, I would say, is like the first step we step from maker product to meet the needs for more general public, because the general public may require much easier control interface to enjoy the robot. Let me do a quick demo to show you the Bluetooth connectivity. First, I'm using this one as a demo. Turn on. And I'm opening this app. It will list all the devices with our device sorted on top in case there are too many Bluetooth devices and we cannot find it quickly. So I connect and it's on. If I press the, let me see how to show them at the same time. Okay. If I press stand, the stand, and there are two areas of the control panel. This part is for the gates. Second, and it can go really fast. Or slow. And it can crawl, walk,
Oh, yeah. Huh? We got a dog.
or run.
Oh,
RZ, you were muted. Can you unmute, please?
When was it unmuted? I didn't know.
There
Oh,
you
no,
go.
yeah, sorry about that. It was my fault.
Okay. And it can do pre-programmed motion patterns like say hi and push-ups. Push-ups. And here is another one. I hope it will go successfully. Watch.
Oh my gosh.
And it can automatically decide if it is fold over. Like I'm not touching it. It's the instinct of this robot.
That's nice.
And give it more room. And it still has the balancing feedbacks. See? So this is a phone basic functions of the smartphone app, and it has some more advanced functionalities or features. For example, if you hold this button and drag, you can rearrange these buttons, so it's more convenient to get access to certain keys. And you can also double click a button to enter a customized button editor. You can type in the serial commands and save it as a special button. So later on, you can get easy access and reproduce certain commands. For example, this one. This command means move the eighth joint to 80 degree and back to -80 degree and back to 0 degree. And if I save this button and press it, you can see this joint moves. This is a very simple coding interface if people want to use the Bluetooth app. And we have more advanced coding interfaces. Now let me bring you to our documentation center, where I will introduce the whole system more systematically. I will share the screen. Okay.
Yeah, we see your screen.
Great, but the letters are small, right?
A little bit.
Okay, let me make them larger. And you see, after a period when I didn't assign any commands, it will go into the automatic mode, just like a living robot, living dog. So let's look at the documentation center. If you want to check this documentation center by yourself, you can simply go to docs.petoi.com. And our website is petoi.com. And on the left side shows the whole documentation structure. Like this one is the welcome page, and you can choose where you start, the Niveau cat or Beetle dog, and inside that it will introduce you how to assemble, because the structure of the dog and cat are different, so you will need different menus. But the other contents are shared. That means no matter if it is a dog or cat, and no matter if it is a Nightboard or the Byteboard, the code structure is basically the same. And you don't need to learn different things if you want to work with different models. And this serial protocol is designed specifically for this robot, because we know this robot has so many joints. If we want to control it in real time, we have to have some efficient encoding methods. That's why I designed this protocol. With different tokens, it will decide the ways how the program will understand the instructions and parse the instruction strings efficiently, especially when the commands is related to the joints. The full model of this robot will have 60 joints, and each joint angle will be encoded as an signed integer with 8 bits. That's 1 byte, and they will be arranged and encoded as a string, a character string. And we can control this robot from multiple layers. For example, from the top layer, I can simply write K sit. The K means it's a skill, and sit is the name of the skill, and it will perform the posture. Or it can be M030. That means move the zeros joint to 30 degree, and so on. It can walk forward, left, and rest. And let's go back to this document. The left side, we have the instruction for the remote controller. It explains how this infrared remote works. And the mobile app. Another functionality of this mobile app I didn't mention was the ability to calibrate this robot, because the robot, after installation, the joints, the servos may be pointing to random angles, and simply by attaching them will not get the joints to ideal calibrated states. We will need to use a tool to tune the offsets in the software. Before, when I was using the Arduino interface, I had to remember all those commands and type and enter numbers. But with this smartphone app, I will be able to use sliders. By clicking them, and I can do the fine calibration. It works with the cat and dog. And this year, we made a big improvement on the user interface. That is the Patoy desktop app. And using this app, currently it has 3 functionalities. The first one is the firmware uploader. Using this tool, users no longer need to download Arduino. They no longer need to install all those dependencies, libraries, because we already pre-compiled the hex file of this program, and users can use the uploader to select the software version, board version, model, and mode. And by simply upload, they will get their robot configured and upgraded. It's more like a consumer product now. And for the calibrator, we also made this desktop version like this. And the third one is very useful, super useful. Even for me, it's a big improvement. It's called the skill composer. Before, when I was designing the movements of this robot, I was using this interface. Let me bring it to you. Like, I was coding all these skills using this number arrays. Because I have a good understanding of the robot, I can imagine in my mind how the robot will behave just by these numbers, but it won't work for other users. And it won't work for me, for myself, when the frames are too many. And this time, with the help of this skill composer, I can do it with ease, and I will show it to you. So now I'm opening up this robot, and I will open up the skill composer here. Can you see it?
Yes.
Yeah, because I cannot magnify the interface, so the letters may be small. So currently it's showing the Nibble cat in the center, but I can change it to Beetle. Okay, now it's in the dog mode. And let me reconnect this Bluetooth. Connect. And I'm going to connect, and you can observe this listening button here, connect. Okay, I didn't press anything. The program works by listening to the serial port, all the serial port of the computer. And once there is a new serial port connected, it will try to send a signal to the port. And if the port is connected to a robot, the robot will return an expected token so that the software knows it is connected to a Patoy robot and automatically update and connect. You can see now the connection is built, right? And if I connect it to another robot, again, check this port here. Okay. Once there are more than one robot connected, the list will be updated and there will be 2, so it shows all. And now these 2 robots can be controlled altogether. And the joints can be controlled. And it allows multiple connection. There can be 1, 2, 3, 4, and many more. And I can also select a single robot, or this one, all at once. And this interface allows me to move the single joints, right? You have already seen this. And the legs. And better than that, I can bind the joints. Like I can bind these 3 joints. And the binding can be reversed. Let's see. Oh, these 2 legs in the reverse direction. And whole body movements. Roll. These controls are Hello, can you hear me?
Yes, we hear you.
Okay, my AirPod just got battery out. So the controls I showed is based on a single frame. That means the current state, it will not be saved in the timeline. But if I use this add button, it will add a new frame, and I can move it and save. And I can add another frame, and I can use a mirror button to mirror, reflect the movement. And if I switch between this, you can see how the movements is played. And I can make these movements looped for 5 times. And I can export this newly designed behavior and save it as some skill. And save, export. How easy it is. Yeah, and I can import. In this import window, I can import the text file, or I can copy and paste the pre-built skills, just like what you see in the source code of the UNO. Like I could import all this array directly into this window. And you can see a new skill is imported, and I can again play or export. If I don't enter the file name, it won't save, but just export. And we can see how it looks. Right? And with this tool, it makes it much easier for users to design their customized behaviors and share with the community. And we hope that with more people to help, we can build a library for different behaviors of robot dog, robot cat. And we're also developing a method that can import these skills into the smartphone app so that other users don't even need a computer and don't even need this interface. just by grabbing their phones, they can reproduce what others has produced. And this tool, first is very interesting and they can really be useful. For example, I have designed some special behaviors that was never seen by others. This robot could be programmed to walk up and upside down on the ceiling. And it can be programmed to go to go between gaps with very fine motion planning to go between gaps, which is a skill that cannot be achieved by wheeled vehicles. And these videos, I was very proud that they were reposted by IEEE Spectrum Video Friday collections. And I was also able to design the motion sequence and use the robots as actors to play some kind of puppet shows. And we made a Halloween video, and it was also reposted by IEEE yesterday.
Oh.
Yeah. So it can be, although it looks like a toy, but it can really be useful and interesting. This is the skill composer, and let's continue. There are many more features. And this is the instruction how to upload the sketch within the Arduino environment, the traditional environment. And API, it introduces how to use the serial master. The serial master is a wrapper class we built around the serial protocol. And within this class, I defined the method how to open up, how to detect and open up multiple serial ports and connect to the robot. Will be automatically. And I also provide the example code that you can design the motion sequences so that you don't need to type them manually, but you can design the sequence. And it's like a script, a play script that the robot can repeatedly perform. And the good thing for this serial master is you can program them on different devices. For example, you can program it on your computer, and it can be Windows, can be Mac, can be Linux. It can be from your phone, if your phone can send the serial sequences, and it can work on the ESP8266. It's a Wi-Fi chip, but it can run C code. It can run MicroPython code. And I'm going to demo with the chip. On this chip, I pre-programmed a script that's a C language. Let me open it. So in our OpenCAD code folder, you can find so many tools. Like this is a UI, this is a serial master code, this is a skill library, this is a source code. All of them are open source on GitHub. You can find them. And within this module test, I can show you this test ESP8266 Wi-Fi. This code defines how to open the serial port and handshake with the robot to confirm that both ends are ready, and then it will run this sequence. Sit down and greetings, push-ups. If I connect this chip directly to this robot, okay, connected. We can push up by one hand. Okay, rotation. So this is one round of the task, and it will loop over and over again. I will just unplug it, it will stop to continue the task. The benefit is we don't have to save all these skills or the sequence on this robot, but to have an external chip, it's like the brain to make the decision, and this is only the motion module. So we can have the freedom to develop this robot from different layers. And the robot can also support Raspberry Pi. This is a video, and this is a picture, and this is a real thing. A Raspberry Pi can be mounted directly to the robot through this socket. This is 2x5 socket. It contains the power, contains the I2C and the serial port, and also the reset. This builds the basic connection. The baseboard, this board can power on the Pi and communicate with the Pi. And on the Pi, it can run more advanced programs. For example, the vision, the voice, the website, the internet connection, and then it can make the perception and the decision. In the end, it will send the decision as string tokens, string commands through the serial port, control the robot as a puppet. And we have a simple ROS integration. It is run on the Raspberry Pi. You may try this by yourself. And we can also develop many demos, interesting demos, like we can use the camera on the computer to run an open pose detector that can detect how your hand moves, how your head moves, and then map all these joint movements to the robot to achieve a real-time avatar. It's fun, and maybe people can find some other users, like can play some roles and let the robot to appear in a show. And here are some introduction to the hardware of this board, how these hardware components are organized, the features, parameters, and so on. This is the Pi board. And we also have many extension modules like this. It's a little difficult to attach those modules on the nibble cat because the head is fixed. But on the dog, we designed this head as a clip. So this gives the freedom to attach other modules. Like I have a box of these modules. This is a very simple light intensity module, but we arranged it on both sides of this phone so it can compare the intensity of the light and to make comparison and make it directional. And we have touch, sound, gesture, and intelligent camera, or like this one. It has our logo here, and it can run the vision algorithm locally. For example, it can recognize human body, face, object, number, symbols, and return the recognized coordinates and conclusion through the serial or I2C port. And our robot don't need to run this algorithm by itself. So it won't have a very high demand of the chip, but it can use the returned conclusions like the coordinate to perform some tracking tasks. That's it. I think I have covered most of our product features. Do you have any questions or do you want to see more demos?
Well, first off, I'd just like to say, and I'm sure you hear this a lot, you are living the dream of most of us, to not only design something that works, but then to be able to see that through into a product and to get into all the different facets of, from manufacturing to support to programmability. I just wanted to say congratulations. This is incredible. I want to be you when I grow up.
How old are you?
Not young.
Not young, but just congratulations. This is amazing. So a question came up a little bit earlier, just to start the Q&A portion of the section. You have a camera module. Now, what does that camera module connect to, and what capabilities does that provide?
Okay. And when I say camera module, I don't only mean one module, but it can be other modules, because we are using quite open standard like the serial or I2C. As long as your camera supports this mode and you have the ability to parse the return to result, you will be able to use these modules on our robot. And on our official modules, we have this module and it will use the groove socket. I don't have the cable here, but the cable, this cable is connected to this module already, but you can see it has a plug and it has the socket on our nine board. So you simply find the correct port, like the I2C, and connect. Then the physical connection is built. Of course, you will have to adjust the code on this board. We have made this demo code already. Like if I open this main code of OpenCAD, we have already pre-built a module mode. If I uncomment this line, can you see these letters?
Yeah.
Yeah. If I uncomment this camera, the code will adjust itself and upload the camera module. The same thing will happen here if I open the Patoy desktop app. Here, I will need to change the language to English. If I click this firmware uploader, it will show this window, and you can see I can select Beetle or Nebo, and they will support different modes. I can select camera and then select the serial port upload. It will do the same thing as this Arduino environment, but easier, much easier for regular users. And for the functionality, this camera, as well as this camera, they have the ability to process the data by itself. This one is still based on ESP32, running some old school vision algorithms. And this one is running a neural network chip called K210, developed by some modern technology. And both can achieve a frame rate of, this one can achieve a frame rate of 16 frames per second, and this one may be 10 frames per second. I think they are good enough to get some real-time recognition effect. And you may check our demo videos on YouTube. The social handle is called Petoi Camp. You can see how this robot reacts to a ball in front of it or to the human body. It will try to stare at the ball in real time.
Okay, got it. Thank you for that. That's the part that I was missing. I was struggling to understand how the Arduino was able to use a camera, but the cameras have some microcontroller attached to it to handle the processing. Okay, got it.
An alternative is you can connect the camera, Pi camera, to the Pi. And after the Pi processes the data, it can send the serial command to the Arduino board. This Arduino board, even if it will go much faster in the future, I will still try to make it to handle the motion. Did I
We've
miss
got
something?
some crosstalk. Let's see what's going on.
Hold on, was that somebody had a question or?
A lot more careful about this time.
I have a question. Hello.
Hey,
Hi.
Thomas.
Hello. So you say this has a Raspberry Pi. Was that the original microcontroller when you first built it?
Yes. And let me grab my old robot, the black cat.
It was Raspberry Pi from the beginning,
Oh,
not an Arduino.
The nibble, maybe? I'm not sure.
yeah, this is the
Wait.
original one right here.
No, the nibble.
Well, the nibble,
Yeah,
The
the
nibble.
original robot was built with Raspberry Pi. And it just
Oh, that's the original. Wow, look at that. You made it
Yeah.
fuzzy. Very.
I'm undressing it.
Oh, that's great. That's very nice. My
It's
daughter
a-
says she doesn't want a robot unless it's furry and cuddly. But she likes your robots. She's a teenager.
Okay. It's a very old robot now.
Oh, wow, look at
Although I'm still trying to make this a product, it's too complex. I would say it's more advanced than my current models, but it takes time to finally make them mass producible. You can see how all these features, like a camera in the nose and
Nose.
infrared lights to give it night vision because it's a cat, and lidars.
Wow.
LiDAR it detects obstacles in the front and also in the front low angle. So it's like 3 detection. And this head is conductive, and this rib is also conductive. So they are actually buttons.
Oh.
Wow.
And
That's a conductive plastic then.
yes, 3D
Oh,
printing.
that's a smart idea. Wow, I never thought of that.
And these legs, they have more degrees of freedom. You can see the difference between the product. It only has 2 joints per leg,
Right.
but this one, and
much
it has these ankles always.
What is the microcontroller for this one?
The Raspberry Pi.
Raspberry Pi. Oh, you like the Raspberry Pi?
I started to work on this with the Pi, but later I actually finished writing the system for this robot. But later on, I realized that Pi is not ideal to perform the motion tasks. It's not a real-time operating system. So I translated the Pi code into the Arduino, and it was quite challenging because when writing on the Pi, I have almost infinite resources to use. But when I translating them into this 8 mega 328p chip, I did a lot of algorithm optimizations in the algorithm and data structure. And I think I'm kind of lucky. It just right fit in the space. And currently the code on this chip is using 97% of the flash. I think it's like art. I'm carving everything perfectly into it, but making it too difficult for other people to modify the code. That's also why we are upgrading to a much larger chip.
Wow. How many employees do you have?
We had one when I was first launching the Nibble Cat. I handle all the research, production, commercial part, and shipped all the product. And then I had Kai as my partner. We met in Kaimana, and he was very into this project after that. Then after I returned China, I kept developing my team. Then now we have 10 full-time employees.
Wow, you've really grown.
It's slowly, but we are growing. And we also got our angel investment funding in 2020 by a very famous entrepreneur and one of the largest internet company in China, by the founder of that company, who is also an engineer who were very interested in this stuff. So he's relatively like we have the freedom to do what we do and don't need to worry too much about other things. So we are still a very focused product company and just trying to make this thing good.
How long did it take you to get the walking gait, the walking for the cat? How long did that take? Was that weeks to get that correct?
Almost weeks, like 2 weeks. 2 weeks, it was already able to walk around, but it takes years to improve it.
Oh yeah, right. You got the basic walk, and then you keep improving, and now you have it works very well. I mean, I'm certainly I'm amazed. It's that it works so well for a little thing, and it stays upright all the time. That's a great product.
And I think with this robot, we really hope that people with more professional background than me can make it work better. Because I was not really in robotics. I used some fundamental principles of physics and mathematics to derive the working algorithm. And I know the modern research method in robotics will use more advanced, like machine learning training methods to generate the gates. But the problem is in their simulation method, no matter how accurate we try to modify the model, there will be a gap between the theory and the reality. But with this model, with our chip robot, they may be able to achieve better results or more practical results. And we actually are already using this method. For example, we know that this robot with this roll, this shoulder roll angle can make the turning perfectly, like almost at the original position. But for a robot with limited degrees of freedom, like it can only walk in this direction, it's very hard to make it rotate at the original position. But we use the simulation method to simulate it first on the computer and then train this gate. You can see how it works. So first stepping and turning.
It moves very nicely, it does.
Yeah. it's a little slippery, and I think the ESP32 version can work even better. Yeah, without the yeah.
I was gonna say, I tried to make a larger robot, maybe about this big and about this tall, you know, and maybe almost a meter tall. And I spent several weeks on the gate, and still it was not very good.
Yeah, that's the problem. And I think if you build a very large robot, then the actuator will be more challenging to design, and the servos won't be enough.
Yeah, I had to use very large servos. You see this is my robot here. This is the lady robot. You see this one?
Oh.
I was making a dog for her, so she could have a dog. That was the goal. She has very large servos here. This is the
frankly speaking, I think it's a little scary.
I like the humanoid robots and the dog robots both. It moves very well.
Yeah.
From I don't remember how much was the original when I got this one on from Indiegogo. I was one of your early backers. I don't remember how much it was, but what's the difference with this original version to the new version? How much can we get the new version?
Do you mean the old version as the cat and new version as the dog?
I'm not sure if my camera's on.
Your camera is not on.
Oh,
is that the comparison?
Hold on. No, I have the. Are you sure it's on?
It wasn't on.
I cannot see who is talking.
The Biddle. The Biddle.
The Beetle.
Yeah. Yeah.
Oh,
I have
Mhm.
I got it from Indiegogo like way early. So I have the original Biddle yellow and black.
Oh.
I don't remember how much it was, but what's the difference for the new one, the new Biddle?
Oh, I see. So there are several parts I won't count, and I will just list them. First, still its appearance. We are designing a new color theme. It may not finally be this, but it will be a more shiny color. Like it will have some red elements. And we are improving the packaging. Maybe you haven't seen this. This is designed for pre-assembled Beetle for later versions. It's more compact and it solves some problems we wanted to solve. And we now officially offer the 9-board controller. Before, during the crowdfunding campaign, it was so-called experimental, but we finally got time to formalize all the code and make it fully functional, as well as the 9-board. And for the servos, we now have a cheaper alternative. The previous one is all metal gear. We designed this all metal gear servo was because we want to achieve the best performance for this tiny quadruped robot to see how to explore the extreme of the performance of these servos. But in practice, we realize that not everybody needs so strong servos, while these metal gears is really increasing the cost of the servos. So we designed, I would say, ODM these servos, with plastic gears, and they have similar performance, but much lighter and cheaper. And we even included some more advanced safety features. For example, before the servos, metal servos, they still have some safety features, like if we push it very hard, the force will be released to avoid damage to the gears. And this time, with these plastic gear servos, we include a structure. I don't know how to translate it properly in English, but you can see You hear the sound, click, a structure is released within it. You hear that? And it's not damaged, but just a mechanism to release the force. And I
So
can
it
even,
doesn't-
it's brutal like.
Like it kind of disengages the gears.
Yes, yes, yes. So
but it does.
this will be much safer than the previous one.
I don't know how he's doing.
How do you, well, it is disengaging and then re-engage, right?
Yes, it's a
Force.
structure here. Yeah.
Oh, this is a physical, it's a mechanical way, right?
But it's
Yes,
not losing.
it is a mechanical way, and the chip, the driver of the servo, can detect this event and then cut off the power later on. Yeah.
It's
That's
detecting,
cool.
it's a force detection, and then it cuts off power. That's
That
really
is
neat.
cool.
Wow.
It's gonna take me a minute to wrap my head around.
Wow, that's
Maybe
impressive.
by current, could it be by current? Is it by current? Detects the current,
Current draw.
current draw, something like
Yes,
that?
by current draw, you can achieve that. But when we
Oh.
produce it, we need to consider the cost. A current detection functionality will require a more advanced chip. So actually, we are using some other tricks.
Okay.
Okay.
Using the already existing standard chip to achieve this detection.
Wow.
The clutch has to be before the final
Yeah.
gear.
When we are building products in China, because the competition is so fierce here in the hardware industry, we want to achieve both good quality, good functionality, but also we are very sensitive on the cost. And people can develop a lot of tricks to achieve the same functionality without sacrificing the effect, and also saving a lot of money, because consider most of the products produced in China are mass produced in even millions units, and every tiny cent saved will be a huge amount of money. Yeah, so they have the environment, they have the culture to save, and I think that's one benefit that I can do this in China. It really helps.
You asked about the price, right?
Yeah,
Because
what's
the current one's $259, and that's still the Atmega. That's the.
But you can buy the ESP board for $60.
Oh,
But can you?
so you
plug
can
it
you
in?
can swap it out. You can swap out the Arduino, the Mega out for the other chip, the board. I mean, you can just swap out the board.
The standard package is still using the 8Mega 328P as a controller, but we now have the ESP32 board called the BiBoard on the shelf. If you really want just buy the BiBoard without the NIBoard, you may contact the support to make a customized offer for you, and later we will make it a standard option for you. As to the price, I would turn to Kai, and I think Kai is also here. Hi, Kai. Hi, Kai, can you hear me?
Yes, I'm here.
Yeah.
Hey, there he is.
Yeah, and you may know him better than me.
Hey, guys. Oh,
Yeah, they are asking
Yeah,
about
Kai.
new courses.
Oh,
I met
what?
Kai at the what was it, the Orange
Maker
County
Fair?
Maker Fair?
Yeah, I was at the Maker Fair.
Yeah, that's where we met.
Yeah. What was the question?
The
The
new
price.
price for the new setup of the Beetle with BiBoard and the plastic servos.
Yeah, so we are on we are going to roll out a version with the plastic servo later this month, hopefully for Black Friday, and we are still trying to get the enough stocks in the US from China. So There would be a lower cost version of Beetle because the plastic servos will cost less. And RC, did you demo the ByBoard?
Yes.
Okay, so with ByBoard, as RC explained, it doesn't have the same extensibility as Nightboard. So, but it has built-in Wi-Fi and Bluetooth connections. So we are planning to release a new version of Beetle with ByBoard early next year.
Yeah, the price will be with some discounts. It can be less than 200, right?
Yes, for the Beetle with ByBoard version. So that Beetle will be equipped with ByBoard and plastic servos. So with discounts, it can be lower than $200. But we are not there yet. So the factories is still testing all the stuff.
Cool. So early next year, you say that all the newer version will be out?
Yes, but there's a trade-off. So if you want to connect some external modules, and the lowest cost of Beetle may not be the ideal solution.
Let me explain this further. On the Nightboard, we have this extensible socket, the groove socket. And to control so many servos, we are using another chip called the PCA 9685 driver. It is used for PWM signal to drive the LED or servos. And with the help of this extension chip, we saved a lot of I/O pins to be put into these extension sockets. But on the ByBoard, it's using the I/O pins of the ESP32 directly without the extension chip. That makes less free I/Os are left on this board. There are still the I2C port and the UART port on this board, and there are also unused pins, although they are organized as the servo connectors, but they can still be used if you use some jumper wires to pull them out and connect it to other sensors. I mean, with this ByBoard, we can still use extensible modules, but it's just harder and it may require some soldering.
That's still a solid design.
How many of these are you making every month?
How many? The production is not a bottleneck, I would say, as long as we have enough supply. But that's the tricky part. The supply is not stable, especially for the chips and like for the batteries. Some of them may be too expensive to have a very large inventory. Some may have fluctuated price. We cannot predict, so we are not having a lot of them. And some of them may have a very large BO MOQ. That means we have to put a large number of orders. All these will also require careful planning of the production, prediction of the sales, and a lot of uncertainties.
So maybe 100 a month, 1,000 a month?
Like for the plastic case, the MOQ is 2K, and that 2K case can be produced in 2 weeks. And for the rest of the season, we no need to produce them. So it's very hard to say how many we produce every month.
I mean, the entire dog, how many dogs you selling?
It's about 300,
About 300 a month?
and we expect to get more during the holiday seasons.
And which sells better, the dog or the cat?
The dog,
The dog sells better. Okay.
yeah, and I think there are many reasons, and the major reason is we are not promoting the cat a lot. It's too hard to assemble, to be honest. If you are a skilled handcrafter or maker, you will enjoy it. It's guaranteed. It has so many tiny structures. You can realize the designing thinking into the structure, but it's hard. Even for me, it takes about 1 hour to assemble a whole cat, maybe more. But for the dog, it takes only 30 minutes for our production line workers. Yeah, so the one reason is because the cat is more difficult to assemble, meaning our customer service will be busier if we sell more of these cats. And another reason is the material, the wood. It's also harder to ship. And we cannot, or we don't want to ship the cat as a whole, assembled. It will make it a very large box. But for the dog, we are able to ship them in these tiny boxes. Yeah, I would say the cat is a hobbyist product for makers. And for this dog, it's a more matured product for the general public. And in the future, we are also trying to go into that direction to make robots easier to use, to be easier to be appreciated by the general public.
Thank you.
Mhm. And I would also say, like, we very like this opportunity to share our project with the whole community here. And because we are operating in 2 countries, our major team is working in China, Shenzhen, and Kai, I think he's too lonely in California with him alone. And we really hope that we can find local partners, collaborators, to work as our California office locally. And especially when we have some events or shows, we would prefer some people who is really into this stuff and can join us.
What kind of collaboration are you looking for?
A lot. Like we are already having different forms of collaboration. For example, we have remote working from home employees. We have outsourced developers for the app, for the website, like for all those software development, they could be remote working. And we also have some local shooting, shooting pictures, shooting tasks, and we may need actors and a photographer and a programmer who can program the robot and shoot the proper scenery. And we also have some media interview requests, who can operate the robot while the cameraman is shooting the picture. Yeah, a lot. And also some customer services. If the customers need remote session to configure the robot, because of the time difference, I can not always be online. And if they are local in the US, it will be more convenient, a lot. And Kai, do you have some more needs or thoughts on this part?
Oh yes, actually we have been approached by a company. They want to shoot a short video about Beetle. So they have a series of videos about high-tech toys, and they are based in LA. So they want to shoot the video early next month. So we are actually looking for someone that can program Beetle and participate in as part of the shooting, as if possible.
I have a Beetle. I could possibly.
How is someone to get in touch with you? Do you want to put an email address into the chat? So if somebody in the club wants to contact you, maybe that would be a good way.
Yeah, so you just email us at support. Let me put it.
Just support, and that goes
support
to you.
yeah. So support that goes to me and RC. The team is behind the email address.
Yeah.
So that's one thing. The other thing is because our product is pretty focusing on STEM market, so we're looking for partners that can introduce us to schools that would use our products.
Yeah. Because since we are already in this robotics industry, we can really discuss about the cool things and also the difficult parts of robotics. And one thing is, if we make robots, how can they be used, and how we can bring values to the society, and so that we can keep getting resources from the society. And I think for our little robot, the major or one real needs application is in the education part, because it's different from the traditional maker kit. It's a real robot, and children or students will be more attracted to this form of robot, to this they will be more excited and feel a better achievement if they can learn something and to program this robot. I think this is the most benefit of the robot. And also for the teachers, they can really teach something new to make their classes different. So we really want to explore the application in the education part. Previously, we have been contacted by a few institutions or schools, like we even got orders from Harvard. They used the robot to do research, and we also got some other universities buying them as teaching tools. But as a company, I would say maybe we are too technical. We didn't promote it very actively to the school. But I believe it is a very good teaching tool, because I started a project in my university, and I used the robot to teach my classes as the first validation of the value of this robot. And when I was writing the code, I put so many thoughts in the program, and it can even be used to teach some algorithms and data structure classes a lot. And another example is, like, you can see this is a book teaching Arduino, published in China, and it teaches the different modules. And I was invited to write the introduction letter. So this is so related. If we can fully explore the teaching functionality of this robot, I think it will bring this little robot to a much larger body of audiences and customers. Yeah.
I want to add that we are finalizing our C++ curriculum, and it's going to be free to everyone. And so if you are interested in in learning or doing some C++ development with our robot, I can send you a copy of the curriculum. And the other thing is, we actually have institution in East Coast, they serve people or children with special needs, and they purchase a bunch of our robots. I think that the main reason is because they see our robot as in the pet form, so that's very different from other robots because human beings are attractive to connecting with a pet. So for children with like autism, they see values of using a robot to get more interaction, to get children to play more. So yeah, that's one thing. The other thing is, we are always looking for press coverage. So if you have connections, let us know. And we definitely want to get more press coverage to people that are into robots, into coding, into programming, building things, that kind of market.
Great.
Well, we're all big fans, so
Definitely. Yes.
we'll promote it in our own way. Tell friends.
Yeah.
And buy more of them, probably.
So there's a question on the chat. Ross is asking if what Raspberry Pi are you using, the 3 or the 4?
For the cat, because it's longer, so 3, 4 all works. And for the dog, because the body is shorter than the cat, so the Raspberry Pi 3A class will be the best fit because it has shorter range. Of course, a 4.
That's the 3 you said?
3A.
Okay.
That's the smaller form of the Pi. But a 4-size Pi can still be mounted, but you will need to tilt the surface of the Pi because it has a large block of the internet connection of it. Yeah, you will need to tilt it.
The 3A is better because it's a little less expensive and it's actually occasionally easier to get.
Maybe, but now I think the Raspberry Pi is on a shortage on all the models. I happen to
Have you had a lot of trouble with the supplies because of COVID over there?
Do you mean for our product?
Yes.
Yes. And mostly it's on the supply of the chips and also the schedule of the factories. If a factory is shut down or the area is locked down, we have no way to get it produced on time. So we have to put more inventory. Means it will put a challenge in our cash flow.
Excellent. Any more questions?
I just wanted to let them know that I can publish their information if they need people. I'm on 3 different robot mailing lists, and if you want, I can publish all your information there and tell them you're looking for several people to help out. If that's useful to you.
Yes, in that case, we need to make a very good summarize of the information to make a nice letter.
Yes, I'll send you my email address and I can contact them for you, or you can go right on there and tell them yourself. I'll send that to you. I'll put it in the chat.
I think this old cat is still alive.
Wow.
It can do this trick.
Amazing.
That's very cute.
So I had one last question about the the whole IMU and algorithms for self-balancing, is that or staying upright with the IMU data, is that a significant effort in the software for you?
I would say yes, but the current version was developed at a very early stage, and after that, I didn't upgrade it too much. It's using proportional control, the P part of the PID. That's it. And I also improved the efficiency of the algorithm, like just to put all the parameters in the form of an array. And some considerations like if the angle is not changing too much, I will skip the calculation just to improve the efficiency. Yeah, and also fine-tuned some parameters and also come up with the idea to store the parameter on the EEPROM. Because if I put all these parameter array into the memory, you can imagine that we have 16 joints and we have pitch and roll adjustments, and we have to use integer. Is that integer? No, float. We have to use float for that data. That means taking more than 2 bytes, maybe 4 bytes for each parameter, multiply by 2, multiply by 16. That will be almost 100 bytes. That's a lot for a small chip with only 2K bytes memory. So multiple optimization in the algorithm.
There's another question in the chat there.
The servos are digital controlled. There is actually, I think, ST chip, ST8 chip in it to measure the signal, to add a lot of logic control, like the protection, like the acceleration, deceleration calculation to make the servo more smoothly, precisely. And also, thanks to this chip, it makes the price of the servo out of control during that chip crisis. I mean.
Okay, well, yeah, I apologize so much for keeping you up so late, but this has been an incredible presentation. Thank you so much for sharing your work and your products. This YouTube clip will be posted to our channel, and we're in close contact with 2 other clubs, one a little bit further north, and then another one in Riverside. So we'll be publishing the clip, and on our forums, we'll publish the chat with all the links and things in it, and it sounds like we'll be in touch. We have a couple of members that are already have your products, and I couldn't help but notice that the ESP board is available online for $60, so that might be a worthy upgrade. Get some more horsepower for free.
That's on the website?
Yeah,
I didn't notice.
Yeah, it's already available.
Perfect.
And there is a sale going on, it's right now for the.
That board is not yet on sale, but we will put that board on sale tomorrow. So there will be a 20% off sale starting tomorrow.
If you're looking for beta testers, I'm sure if you wrote to this mailing list, you'd have a lot of people who would say yes.
Yeah.
Thank you very much.
Very, very good meeting, and I really enjoyed it. The sign is I'm not feeling sleepy. I expected it's already 90 minutes. I thought, whoa, I will make it really quick, and I want to sleep, but no, I'm not sleeping.
The hazards of starting a small business.
Well, we certainly appreciate the time. We've all been following the story of you and your company closely, and hopefully we can reconnect in a bit. As your company and your products and your progress continue to advance.
yeah, we would like to have you back some other time if you guys want to do another talk, maybe, I don't know, when you guys
Sure.
have another update or something, let us know. We'll
Yes.
be happy to have you again.
Yeah. All right, thank you very much. You're welcome to stick around. We've got a few more presentations and some show and tells. You're certainly welcome to stick around if you'd like. We can understand if because it's so late, if you're not able to, and we'll talk to you again soon. All right, thank you.
Thank you.
Very much.
Thank you.
And
Thank you very much.
with that, I believe, Jim, you have the next presentation? Sorry.
Yes, I guess we'll get right into it. And everybody can take a break if you need to. I'm going to, I want to put up orange here so it can be seen. So I'm doing a kind of I'm giving an overview of Orange over the past few years of work since its creation. I'll just put it up here. I can turn it on, but it's,
Yeah. On the table.
Yeah.
Well, yeah, I guess I don't need to. It's not gonna move anywhere, but might as well to prove my confidence in the robot. All I have to do is hit this, it'll stop moving.
If you keep
So,
adding stuff, eventually it's gonna be giant orange.
Yeah. Well, yeah, that Thomas pointed out, it's not at eye level by any stretch of the imagination, unless you're a 3-year-old maybe, but so it may be a tower, or maybe I just have to get a new platform.
Well, you can do the same trick that that new Amazon House Sentry robot has with that telescoping rod.
Oh yeah, right.
So it can put a camera on a telescoping rod and get some height.
Yeah,
So
exactly.
you can look at it, put the screen on the telescoping rod with the camera. And
up there, yeah, exactly. That
so it'll be.
If it would probably. I mean, it may have to have a redesign though to support the weight and everything or balance, but maybe it could be possible if it's a, if it's something that's mechanically well designed that will go up and still, be balanced and with the weight. But yeah, it's possible. I don't know if I'll stick with this, this platform forever, but if I could do that, I might do it.
I'm starting up.
Oh yeah, I won't actually have him start up.
Hello, my name is Orange. Pleased to be at your service.
I won't have him do that. Oh, I didn't bring the keyboard either. Don't want him to do that because he'll start listening to everything we say. So here, I made a new presentation and I gave this one at the last meeting of the Homebrew Robotics Society up in Northern Cal. So I apologize if any people have already seen it, but I wanted to give it to this group as well. So Big Orange, as a reminder, is an attempt at a home service robot proof of concept, all from off-the-shelf components. This is what it looks like. And the main first component is called the HCR platform by DF Robot. And it's a nice platform. It comes with Omni wheels as well as the current configuration I have here, which are regular wheels and a caster, 2 wheels and a caster. It comes with these 12 volt motors. I don't want to join audio. And these are the parts that it looks like. Pretty easy to put together. The other major part of Orange was the SlamTech STP Mini, a product from SlamTech, Shanghai, product and a company that I've been in communication with now for over 2.5, 3 years, more than 3 years, I guess, with their support group and for this product, which became the heart of Orange after disassembling it and putting aside the motors and keeping the LiDAR and the main board in there, the microcontroller board, and it also has the Slamware core board, which is a whole Linux system. So this thing packs a lot of punch. Dr. Bruce and Gary and Alex found. I think it was Alex. I'm not sure who originally found it, but so it's the other major portion of Orange. So now I'm going to go over the hardware, the levels of Orange. So at the base level, you have your motor, and this all came. Some of this came with the original Orange, the home care robot. You had the motors, the wheels, and all the platform, of course, the bumpers, all that you see that is orange and that's metal there. That all came with it. But you have the motor controller, which was purchased separately, and I mounted that. And sonar sensors, which are separate. The LiPo battery pack, which is a 12-volt and 5-volt supply pack, which is served quite well, although it might be getting, well, it's definitely being used up a lot quicker. When I first got this robot, it would last for days or weeks of work. Now, a few hours with everything on, it's gonna, or even less, and moving around, it will use it up. Also, there's the rear, you can see the rear charging connector. There is also, let's close this. That's something I created by 3D printing, modeling after a vacuum, robot vacuum design. So we'll show you that later. Level 2 is got the SlamTech, right? So this is the insides of that SDP Mini are on this mounted on the second level, or at least that one board, the breakout board. I guess I should use my mouse here. This is the breakout board. This is my homemade power rail for 5-volt and 12-volt connections. Then you have your the OAK-D for obstacle avoidance. This is the second OAK-D. It's used to publish depth clouds data to the Slamware. Slamware is this silver-looking thing right here. It's on a card that plugs into this board. This board is an STM32 board, the SlamTech breakout board, open source board. It has Wi-Fi. It has the Slamware core Linux system running on this board here, a whole Linux system, and it handles all of the I/O. The STM32 handles the I/O to all the sensors and the motors, et cetera, and they talk to each other. And it's also Ethernet, Ethernet controlled. This whole board connects by Ethernet to your higher level system, your PC, your PC. They also have the audio speaker amplifier that I just repurposed this from a home use. I bought for a little portable speaker, Bluetooth speaker. Now I'm using it as a direct plug-in with a speaker output as just an amplified speaker. So and I have a different microphone. You'll see that in a minute. So the next layer, level 3, has got the RP LiDAR A2, which came with the SlamTech, which is instrumental for navigation and SLAM. It feeds into the Slamware board and Slamware core, and provides the main data for navigation. The next level Level 4 is the PC, or the top level brain, the Latte Panda Delta. There's a new one out now. I may upgrade, which is, although it's maybe double the speed, but it has more memory. I'm not sure if I should do that yet, but it also have a 7-inch touchscreen for that Latte Panda, and that's running Windows.
Hey, Jim, if you want to sell the old one, I'm interested.
Yeah, well, I may. I'll let you know if I want to sell it or whatever. But the you can buy those online. I have links at the end of this presentation with all the hardware. So level 4.5 and 5. 4.5 because the ReSpeaker microphone array, ReSpeaker V2. Actually, I should have put that in there. The ReSpeaker microphone array is a 4-microphone array system that has cancellation of noise and is a far field microphone array, so it can hear you from across the room. I've demoed that and recorded videos for that. Slightly above that is the millimeter wave radar sensor, which can, I'm still experimenting with what to do with it, but the demo I did was it can discover a person behind a barrier or like a door, and it's a bit of a detection feature. It can detect people in the room without using the visual camera, so if people are moving. So it's another sensor to see if someone's moving or still. And I may upgrade that to the latest version, which is instead of the current, I think it's 24 gigahertz. It's 64 or something. It can do better detection of people, and so that way you can tell, oh, someone's entered the room, and even with the camera off, the visual camera, which eats up a lot of power, by the way. And that brings me to the OAK-D for vision and depth. That's at the top. That's the real brain, or the visual brain of the robot, which can help it. It helps it determine what it's looking at, where that thing is, and the ability to go up to that object or person is all contained in that. And that the OAK-D, Luxonis OAK-D, is my favorite peripheral to this system. And I'm still discovering more that you can do with it. It's a stereo system. It can stereo camera with depth, disparity depth, and it has a full engine on board to do computations of a neural network inferencing. So it takes a load off any of your other hardware for that. So it's a hardware solution, and you can upload those software. It's compatible with OpenVINO, and it's Intel Movidius, Myriad Movidius system that really can do so much. I'll show you a little bit later, but the other big aspect of the hardware is the base, the charging station, which is a homemade concoction of a robot vacuum charger, which you'll see I mentioned about a eureka moment when I purchased a Nito bot vac for a Ross project, and I noticed that the base charging station for the vacuum was kind of almost perfect for my robot, and the other part of this is a 3D printed what they call a charging pile that you see that's sort of faded mixed color white up above, and that is a design that the Slamware system knows how to detect, and those little caves are detected by the LiDAR, and that's how the system hones in on its base. At least one way. There's two ways. You can also use infrared beacons. So, but I had to design that part. Not design. The design was written on a piece of paper, essentially, or on a web page, and I took the design and brought it into Fusion 360 and made it into an object so I could print it, actually in 2 pieces and glued them together. So that brings me to the 3D designed and printed parts for Orange. It's got quite a few, or I guess not, I mean, obviously not as many as a robot you have to make totally out of 3D parts, but this robot is mostly metal, but obviously I needed a bunch of, as time has gone on, I've built more and more plastic parts to handle things that the original design doesn't handle, especially the tray. The tray was kind of the biggest item, and that was, for the contest we did, the Open CVAI contest a couple years ago. We wanted to be able to serve drinks and at least carry something, and you put an object on here, and the OPD camera looks down and sees what it is, and then can say, okay, I'll take this spoon to so and so, or this bottle. So that was a really important add-on. Then you've got the antenna mount, the charger, the rear charger mount there. That took a lot of design work to make that little part, because I had to model the whole the base of the robot in order to make sure it fit. Then you have a charger riser. That's for that vacuum base charger, depending on whether it's on floor or carpet. Of course, it has to be whatever carpet I have, which is it's a low nap carpet. Deep nap carpet, I don't know if that would work. You might have to have a different riser. And then the pan tilt mount is where the OPD, the upper OPD is. The radar mount was the newest one, the little door. And then the speaker base is something I added to keep the speaker secure, which it didn't used to be. I was wondering for a long time, how do I keep this speaker from falling out? And I had little glue and different, little like putty to keep it in, or tape. And I was like, that's, this needs to be done more securely, professionally or something. And then there's that SlamTech charging base. So yeah, a lot of, for some of these, it's like, I was like, I can't just I can't just like dangle some device on here and hope it stays. And that's when I actually did this last one, the speaker mount. I was taping this speaker array to the top, and I'm like, all right, let's make a mount for it. And I was able to do that. So that it's kind of mechanical engineering by need, I guess, and mechanical design when you're tired of things falling off the robot.
Necessity and invention and all that.
Yes, necessity and invention. And the Latte Panda and screen mount from Thingiverse, I didn't have to touch that. That's just very convenient. Oh, too bad the columns messed up. But so the overall cost, at least from my estimate here, these are the sort of breakdowns, and it's weird. It should have the total somewhere. So
it's in the middle.
Oh, there it is. Jeez, this has got. Oh, it's because of the screen, maybe. I don't know. So around $2,100 as designed. Miscellaneous. Yeah, there's some miscellaneous parts. I didn't really count in any time cost. This is all just parts cost. The time is is a lot of potentially a lot of money of your own time, but the biggest parts are the $500 SlamTech STD Mini and the $530 home car robot chassis, home care robot. It's funny. And yeah, the rest of the stuff isn't that expensive. Oh, the OPD cameras are the other kind of expensive, and the Latte Panda. But all of these are still available. The SlamTech STD Mini is getting hard though, and it's kind of old and not supported. I don't necessarily recommend you go with all these parts. And there's some age to this whole system and availability, but it is still available. Almost all those parts, pretty much all those parts. So that's now I'll talk about the SlamTech Slamware, which is kind of what got us going on this project. It's the core of the technology that helped us leap to work on advanced robotics instead of kind of muddling in the lower level stuff and struggling with that. Now you could go and I mean a lot of people love to spend time in designing or coding up things involving like the LiDAR or the the sensor fusion or the docking algorithm or the SLAM. But I mean, most of us, even with ROS users, you use the SLAM system that's there. You use nav2. You use but the difference between ROS is I see a lot of people struggle, and of course the ROS2 conversion has been a lot of work, but for average hobbyists. But the Slamware system is designed as a turnkey system, and it's not as much of a tinkering thing, although you can do a lot of tinkering, but it's got a full API that works out of the box, and you just have to be a good reader of manuals and ask questions from the tech support if you get confused, and they did respond quite well for me and a few other people. So yeah, the Slammer can handle all these different sensors, and I've implemented. Obviously, I use the LiDAR, ultrasonic that came with it. Ultrasonic sensors were added. Don't have Cliff. Don't have the infrared hooked up. The impact is, I guess you could call that the bumpers. The depth camera, and I have that too. And yeah, I told you about the infrared beacon. So this is proprietary. This was a commercial product, but it was instrumental in kind of helping get going with an advanced navigating robot. And you can see this breakdown here. This is one of their diagrams I kind of modified. The top level they call the man-machine layer. Wi-Fi, the LCD, the depth camera, then that's the sort of the microphone. Then the middle layer there is the Python. Where I have is my Python and C++ apps running on Windows, and the Latte Panda single board computer. They call that the customer service layer. And then below that is the SlamTech technology, the LiDAR, the Slamware core, which is that, in this case, it's a white version of that little board. This is all communicates via they call it high-speed bus. It's an Ethernet. So Ethernet between that first layer and the second layer. And now you also have on that layer is the MCU, the STM32 control logic. All of that's open source, by the way. Well, everything above. Well, not everything, I guess. Everything in that, in this is closed source, in this device, but it's got a full API, and all the code in the STM32 is open source. And I had to, of course, modify that to adapt it to my motor controller board and mainly and other sensors, power detection, battery detection, or battery current or battery capacity detection, that kind of thing, by using, well, I just use voltage. It's not a really that sophisticated of a way, but voltage divider. But you can configure that software and you build it in C. It's C code, and you compile with an embedded systems compiler that's free for this type of use for under a certain number of K. It's called IAR, and but it's pretty straightforward. If you need to be a C programmer, but that's an instrumental part of the development was working on the STM32 code, and then below that is the robot base, the H bridge. That's your motor controller and encoders the wheels or the motors and the sensors. Other sensors are connected. Well, yeah, the sensors are connected directly to here, like the sonar and the infrared if you have it, etc. So there's sensor data coming from two places. The depth camera goes through the PC, through the internet, through Ethernet, whereas these lower level sensors are plugged directly into the GPIO, the IO ports, and the bumpers are, of course, are plugged directly in as well to the microcontroller. And then yeah, you can see over here okay, now this is the Slamware core. Slamware core does all the high level or all the kind of difficult to program work that you may not want to do yourself, like SLAM itself, the location automatic locating itself and mapping, as well as the what you call routing, or the D-star engine. D-star is essentially dynamic A-star. If you're familiar with A-star is path planning. That's what I meant to say, path planning. Path planning in the most traditional. We've had a lecture on it a few years ago, but dynamic A-star is this is used. It's a more advanced version, and it will path plan through a map from one place to another, avoiding all the static obstacles that were in the map for you. For dynamic objects, we use obstacle avoidance using in this case using the depth map from the OPD camera. Or the sonars. Sonars also can give back dynamic data and without mapping. The map is fixed at that point, say, and you put an object down in the room. Mapping is off because you don't necessarily. Once you map a place, usually you clear it of people and animals, and map the room, and then save the map and turn off mapping, and then use obstacle avoidance for the to avoid objects that just happen to come in to the environment. So the motion control, again, this communicates over Ethernet to the higher level of the PC and can give you the pose of the robot. So through odometry, as well as the LiDAR and the map, it gives you back, and the IMU. All that stuff is done inside here, and it gives you back a pose. So it's like if in ROS you have those capabilities, except it's a bit more, manually. You have to kind of piece together those things yourself. And I'm going, I want to learn more in ROS to do it, kind of to learn sort of, a slightly more manual way of bringing these things together using your nav2 and your cartographer or the planner, but this is a more easy way to get into it. I think it was easy that you didn't have to connect a lot of pieces. You just make calls through an API, and you had to do the low-level coding of that SGM, make sure all that piece was together. But once that's working, it's pretty solid. I mean, it's like you're close to the hardware at that point. If it's not working, it's not that much code they have to fix. You either got it or you don't. It's and it's not. Once you get that working, that code pretty much stays. You don't need to debug much in there because it's so little. But if you had to debug, these higher level things like SLAM, oh my, or A-star, or even like with ROS, you have to debug the interaction of these different things. Even though you're not actually debugging A-star, you're debugging how does the data get into how does nav2 deliver you the info? How does the transform TF, transform matrix or stack work? Whereas this this system handles a lot of that for you. So real-time localization. You can one good thing about this system, you can navigate without a map right away. So it comes up with a coordinate system, and it maps whatever it sees right when you turn it on, and it creates a map and a coordinate system. So then you can click somewhere off the area where the map has been filled in, and it will attempt to go there a little at a time and mapping as it goes. So, and that will work quite well. It can work quite well with mapping as you go. And in fact, I do that in one of my demonstrations. I turn the robot to follow me mode, and I can follow around the house, and it will map as it goes. All you have to do is don't go too far away from it, so it can still, see you, and with the camera. And then as long as you don't kind of trick it and go behind an object, if you do something, you're not going to be walking into an object. So usually when you're walking through a clear area, so the robot can follow, and it won't hit anything. Of course, if it, you can also, the dynamic obstacle avoidance will work as well, and the bumpers as a last resort. So pathfinding, yeah, it's got this built-in 9-degree IMU. I never have to do anything with the IMU. It's just using that info, and it's fed directly into the SLAMware, and it helps. You don't even know exactly how they what they're using, but they're using that as part of the sensor fusion. And certainly, if the robot, certain things it's used for to help in orientation, and probably accelerometer, but that's kind of opaque to me, right? I've not needed to look into how they're using it or access it myself. Pathfinding is with the, like I said, D-star, and again, I just tell it, go here, and it will make that path, as long as there's a map. If there's no map data, it will still try to make the path, and then it will make a path, and then as it goes, it will remake the path when it detects a wall or something. There's the 5 centimeter, I need to move faster here. 5-volt power. This is what the board looks like. You've seen that. GPIO, motor IO. So a lot of this project was learning how to use this piece of hardware, and learning how to integrate and use its API. The way you saw that diagram where it showed you the communication layer, well, it's Ethernet, but from the Windows side, you're making calls that are high-level API calls, and those are automatically routed over the internet, over Ethernet, but you're just making a call from in a C++ call that says something like, go to XYZ location or XY theta, or give me back what is the, where are you? Give me the robot pose, or turn right, turn left, things of that nature. You can even query the map, all sorts of things like that. Here's the overall kind of diagram. Thank you for Brian for making one of these diagrams of his robot, and I kind of use that same software and or use the Google Docs, I think, and replace everything with all the mic pieces. Of course, some of them are the same. Like I think we both have the USB 3 7-port hub. But in any case, this is it's a little bit. There's a lot here, but essentially all the different pieces, and this is growing as time goes on, adding in more devices. I've got a few USB hubs still left open, but it's not many. Software. So the Python application is the top level brain in functionality, and there's submodules for many different functions of sensors and voice systems, etc. The SlamTech DLL in C++ provides Python bindings to the SlamWare API. So this was done, and this was done back with when Dr. Bruce and Gary and Alex were involved, and they created the SlamTech DLL. Then I've been adding on to that ever since, because we started out with just a few functions, and so every function I need to access, I add it to the SlamTech DLL. But we don't, only bridge over the functions we need, not the whole API. The whole API is hundreds of functions, and it's not necessary from the C++ API. And the STM, as I said, open source, and I configured that for Orange's motors and sensors, like the battery detection, as well as the sonar, things like that. The Leonardo controller, this is in C++. Leonardo, if I didn't mention, is part of the Latte Panda. So Latte Panda conveniently comes with an Arduino, essentially built in, with all the pins exposed. And I figured, might as well use it. Like Dr. Bruce added a couple of Arduino Megas. And I was like, okay, I bought some, and then I'm like, well, I might as well use this built-in one, because there's a serial port built in directly, and it's all connected. So I mean, it's part of the same board. So you just use COM7, and you're connected to your your built-in Leonardo. I wanted to access everything from Python, so I used this thing. I gave a lecture about this, or part lecture, before, using Fermata for Arduino, and which is a serial communication protocol. So you can communicate to your Arduino with a standardized command structures. And I had to work on that code too, actually, to add to it recently for the radar. The radar, I needed to modify the standard Fermata, and also to be able to handle the servos at the same time. That was a little bit of a project. The depth cam publishes C++ code, which publishes depth maps from the second camera. And then the manual controller, that reads the game controller input, so you can move around. You can do teleoperation. And that's a C++ program. All these running on the Latte Panda. I guess, all of them pretty much. Obviously, the Leonardo is running on the microcontroller. Here's the top-level view of the block diagram of the software stack, of the high level. So main, this is all in Python. Main Python module, which handles all of the main loop of the program, and all of handling all of those, creating the threads, etc. And these are the different modules that I've written, or that I've linked to. Actually, I guess this layer, the top layer, is all the ones that I've kind of written, or partially taken sample code, etc. Then the second level are all pretty much out of the box libraries that you just install. So moving the OPD, that's the moving the eyes, the radar, not to be confused with displaying of the eyes, is using Pygame. Pyfermata, again, used both of these, radar, and so those both communicate to the Arduino. I guess I could have put that somewhere here. That connects to the Arduino Fermata side, it's a client-server relationship. So then you've got Deep Horizon's text-to-speech, uses Windows Snapping, speech recognition, VOS, facial recognition, human pose, object recognition, and more to be done, all using the Depth AI system on the camera. on the stereo camera from OAK-D. And then below that you have I think I just mentioned this, the SlamTech DLL, and then SlamWare SDK Windows. And in between, we needed to have this Python to Win32 64-bit conversion thing. This is kind of a bother, which would be nice to, to get rid of. That's why this whole system is a little old, 32-bit. It's kind of with the SlamTech stuff with this particular product. So, and it doesn't seem to be upgradable. The pixel ring and microphone array. For actual runtime, these are the threads. We have the voice recognition and command, the display, the OAK-D AI thread with either running YOLO, MobileNet, facial recognition, or Pose. I'm trying to combine these so that more can run at the same time. That's just an exercise I have to do. So right now, it can it's just running one of them at a time, either the YOLO, the MobileNet, facial recog, or Pose. But yeah, it's just a little more detailed coding to integrate. And there may be some limitation, like I can't maybe do everything at once, but but I can certainly do a little more. And even these operations, like while it's running MobileNet or YOLO, it can still do stereo disparity and figure out where an object is in space, and can also do object tracking. That's all. Like there's some things that are operations that are can be already done at once using just one of these. But yeah, those were sample codes, and they did not have a sample code that combines, the facial recognition and the Pose and the MobileNet all together, because it's kind of a bit of a complicated pipeline that you have to put together in the code. So go to location, time thread, that just keeps track of time, display. And then these are all the sort of spurious or active when necessary threads. The radar, the tracking, person following a person, handling an asynchronous command. For instance, you can type in commands from the keyboard on the screen, and it will do that asynchronously. Sends off a command. Deliver to person, that's the more advanced ones. So the voice commands, this is just a quick summary of some of the more notable, or the movement ones. Go across the room and come back, and go recharge, go forward, go to location, recover location, load map, update location of, so you can tell it where, mark this where you are. Voice commands, these are the complex commands. Find the object in, like a remote baseball and then a certain room, or you don't have to say that, and then it will search the current room. And the searching algorithm is not that sophisticated yet. It just kind of it finds the furthest away point it can see and goes along that line of the room. So it's trying to find the length of the room, and then it sweeps back and forth its head to see if it can find the object. But so it doesn't do some sort of really advanced find an object, but maybe I'll add more sophistication. Take a picture, what do you see? That uses the edge GPU. So technically the robot has two AI systems and hardware. The edge TPU, Coral edge TPU is on board as well. That's connected directly to an M.2 slot in the Latte Panda. For facial recognition, you say, I am so-and-so. It'll recognize, it'll remember your face. Now it points up, finds your face, stores it, and then later you can say hello, and it will look up, do the same, find your face, and then look up its match to see if there's a match in its database and call you by name. take these or this object or one or more names in that location. So that was another, this was the delivery system that we did for the OpenAI competition. That was a lot of work. The track me and follow me. I got some help from Scott Horton, thank you, that he did with his Elsa robot. And we actually were able to share code, one of those rare moments in hobby robotics that I really like when you share code in Python. Also, Dr. Bruce, of course, shared code, and I'll just give some credits at the end. Come Here was one I've added more recently. And so using the microphone array can detect which direction the voice is coming from. It turns to that angle, to that direction, and so then it sees you with its camera. And so as long as it turns pretty close to the right direction, because the microphone array is not perfect resolution by 1 degree. It's it's not, but it turns enough, and then it will find you visually. And then the latest one I added was Go There, with pointing to place on the floor using the human pose. Any questions so far? I don't mean to ramble on here without, just we're kind of late on time. Hopefully I'm explaining things. But this is the chronology. 2020 started out as an Arduino-controlled 2-level thing. And then a little later, just 1 month later really, I added the SlamTech in. And then by November, I had to connect the screen and pretty much all the levels. Then in March of 2021, the Oak D cameras, the webcam, speaker and microphone, and then the cargo tray in April, and then second Oak D in June 2021. Then the eyes came in 2021. Then the speaker array in 2022, and then radar in October, which is pretty much the latest hardware. Here's some video highlights. Which I've got over here. Let's see.
Hey Jim, I got to bail. Thank you so much. I was impressed by Orange, and I think you're doing a wonderful job. I just always love to see the new and improvements, and I can't wait to see him in person again. Maybe come out to Riverside. Can you bring him out to Riverside next week?
I don't know if I'm coming next week, but yes, I definitely try to bring him, especially when there's something new to demo.
Oh yeah, I'd love to see him in person again. I really would. All right, I got to bail though. Goodbye, everyone.
All right.
Good seeing you all.
Thanks, Thomas.
Hopefully
Thomas.
some of you will make it out here to Riverside. We'd love to have you out here. Hey, I'll buy lunch. You come to Riverside, I buy you lunch. There's a standing rule there.
Bye, Thomas.
Goodbye.
Right. So just to look back at the whoops, let's I'm not sharing the whole screen. Pardon me. So they're looking back.
Wow, that's a pretty good going.
Okay, let's see the maiden. So this was the first time I. It's a little. Let's see if I. Yeah, from here I definitely need to use that optimize the video clip. Let's see if that. I want to see if that works. And you can see the screen. Let's make him go right. So this was the maiden voyage of this device, and back in 2020. And all it has is an Arduino with a little Arduino screen. Try that again, left. Or it's actually an Arduino built into the screen. A nice little product that continued. company owner. So yeah, that was that. And then, so I put together a little array of the of sort of highlights, only like 10 videos or something. And then if we jump to, jump to the end here, you go, well, you saw the point to goal. I don't think the people saw the funny one though, but at least, yeah, you probably saw that last time. But I guess it's a good one. Facial recognition upgrade. But yeah, this one was kind of funny. Orange, go there. Oh, this is the one you've seen, but.
Okay, I am going.
So this is where it's come after 2 years, where it can do that, go where you're pointing. And yeah, you guys saw this last time, but for instance, the one you might not have seen, or did I even upload it? Oh, I think I uploaded the funny one. Let me see. Okay, let's see the maiden voice.
Why we use Miro?
Well, when I draw on a whiteboard, nobody sees it.
But with Miro, we
So this is the kind of the joke one. Orange, go there. Why is it a blue?
You have it selected.
How do you unselect? Orange, go there. I don't know how to.
Take it out of full screen.
Oh, there.
There you go.
Huh?
Take it out of full screen. And click on the screen.
Jeez.
There you go.
Orange, go there.
You'll need to call NASA for my jetpack.
So yeah, again, that it's a lot of behavior going on there where it's pointing up to see your face, and then it's determining where you're pointing via the human pose, and then it has to determine, oh, it's pointing up, so that's in the sky. But one of the best videos we did was the delivery. Obviously, that was a big achievement. Let's see. We go back to the playlist here. Just go back to the presentation. But yeah, all these videos are on. I guess I'll just skip that. All the videos are online, so you can check it out. These are the milestones. In the interest of time, I won't play any more right now, but the milestones is just a few of the best videos, including the delivery and all that.
Okay, all right.
I just don't want to get people too hungry or myself included, but if we can jam through. There we go. Back to the full screen. How do you get rid of this thing?
Oh, did we lose the sound?
Oh, I muted, but then I unmuted.
Oh,
Yeah.
okay.
So yeah,
Sorry,
what do we got
we're
left?
back.
We're on slide 27 and there's 37, so there's good 10 left for this. But yeah, I guess if we do have a little time, then I'll show. But yeah, this is the video list. You can go look at these, but just these are the highlights. We did SlamTech based robot, Big Orange follows voice commands. That was step, and then version 2 had the I think the first Xbox Connect and depth map publishing, and then the Floorbot challenge was go across the room and come back using the LiDAR, finding the furthest point of the laser hit, and then telling it to go there. The Coral Edge, this was the first time I had some AI involved using that Coral Edge TPU, where it could classify a bird or an insect, or that's pretty neat stuff. That's just up, and you could make your own models with that Edge TPU. There are instructions on doing all that. I didn't. I didn't do. I trained another one on flowers for that Google Vision AI kit, but this Coral TPU is quite useful. I just it got kind of sidelined. It probably feels slighted because if a machine could feel, because the OD kind of took for center stage, But I should get back and use that Coral. Then this was of course the big one that Brian and the team, the social distancers, were involved with, which we delivered to a person in another room and all that, delivered a bottle. And then the docking, the follow me only, that one was involving tracking, well, first of all, the following system, and then also tracking people so that it would stay on you, not go off with somebody else. Of course, that's limited. It doesn't, it doesn't work if you go off screen. Then it will start following somebody else for more than a second. But if you stay on screen on camera, it will work. The come here behavior, then the microphone array with offline speech recognition, then the detect movement through a barrier. That was using the radar. Then facial recognition upgrade, where it points up and finds your face instead of, so it didn't used to do that. It would just point up to a certain angle and hope your face was there. That doesn't work if you're like Walter Martinez, 6'2", and me, 5'3" 4. Anyway, or causes somebody's back to ache if they have to bend down. Facial, and then the point to goal in the sky. Point to goal, as you just saw. Back to this from current slide. So challenges. Someone asked about this for me to add in a slide on challenges and eureka moments. There's a lot of them, but the ones I came up with were some of the challenges were like when you're going through this every one of these tasks is kind of like, how am I going to do it? And even with this hardware and the software, the sample code doesn't do that, directly. Which sometimes if you're lucky, you can find sample code that may do almost exactly what you want. But rarely am I satisfied with that. I think it's like, okay, it does that. Now what am I going to do with it? Because that work's already done. Otherwise, you have no work. So, for instance, detecting if an object is really there, the camera gives you these frame by frame. Object is there, or it's not there, and it's frame by frame. There's 30 frames a second in a normal camera, say. When is the object really there? You have to integrate. If it's just flickering like 2 frames out of 30, that's not really there. So integrating over time, using sort of a filter in the software to detect what percent of time is the object there of that particular identity. And that was kind of an important milestone for me, to be able to say, okay, the remote is there long enough to be really there, as far as the way this type of system works. The classification or the detection, the little bounding box you see, can flicker. And so that had to have software to get it to reasonable detection like a human can do. The docking station was a big deal. I was, I was trying to figure out how to do that for a long, long time. And then, as I told you, I got the Nito bot back and all that, and that came to fruition. And then making Orange follow me was a big deal. And I thought, no, that's too hard, and how am I going to do that? And then, I got some help from Scott Horton, and as well as realizing that it wasn't quite as hard as I thought. His robot's totally different from mine, runs ROS, so it's totally different, but the concepts are very similar, but using the same camera, same OPD. And then dealing with the background noise, with the famous aquarium incident where nobody could hear my robot, and I said, I'm spending a month on this or whatever it takes to fix that. So adding in modifying the software, the speech detection, speech detection, and doing this energy thresholding, which was already kind of there, but it needed tweaking and adjustment for my particular, I kind of improved the code so that it would work. And now even at the Maker Faire, with all the noise of the whole woodworking shop next door, I could actually give it commands, and they could hear me. So isn't that thresholding? So that was an important moment. The wish list. Take these objects to one or more names in basically a specific person by face. So take these to Alan, and it'll go in the room, see multiple people, and go, oh, that's Alan. I already have the pieces to do that. This is more of an engineering task, right? Because I already can detect faces. You'd have to look at it. Obviously, you won't be able to know who's who unless you're facing it. But so that is a problem. It may have to, have to move around its camera a bit and try to get a glimpse of the person. But most people will generally look at a robot if it's coming at them, sitting at a table. Dance with me using the human pose detector. I wanted to kind of, if you made a movement, it would kind of, do whatever it can as a cylindrical robot, like at least body movement. It can move back and forth, or forward and back, or something like that. And then find a person by face. That's almost the same as the first one, really. So it can go around the house and find a person. Notify me if anyone else comes in here. That's sort of using the radar. Automatically map the room and the house. Where is my phone? So I wanted to add in, something like a database. Use Prolog and have it store information about its environment and as it wanders around. more things. Wake word, actually the future development, on the top of the list right now, because it's annoying the heck out of me from demonstrating this to people live. But actually, the best way to find out what's lacking in your robot is bring it, demonstrate it to your father-in-law or to someone who's a non-roboticist. And now he laughed a lot because it was spitting out all sorts of weird, responses. But I mean, they was laughing, and that was more funny than actual functionality. But the wake word is really important. Otherwise, Orange listens to everything you say, and it's just more processing power, and it's a little harder to talk to him because he's always thinking about what did I just hear. But if it was wake word, the wake word using Mycroft Precise is the one that Scott, the other Scott, is using. With his robot, that will it won't use up any processing power to process all of the language, what it hears. It just listens for the one word. You have to train it, and it's a bit of work, but then it will then start listening. Once it hears its name, it will then, or 3 syllables, then it will start listening. So that's a big improvement. And that will make the robot more responsive and not always trying to process what it just heard. Like this conversation, we're having here, it wouldn't, until you say the word orange, it wouldn't even be processing that through its speech, to text. And then more complex commands, facial, and what would you want it to do? Send me an idea. So here's the links. This is mainly for you to look at these slides later, but all the links to the hardware, and there's 2 pages of those, and then neural networks on the OAK-D. These are the ones I'm using so far, and there's dozens more, really. There's so many to the neural networks, and the sample code is quite good, I think, and it's a little hard to integrate them together, like when you want to use multiple behaviors. The solution for that is you just unload one and load in another one, make it modal, which is not ideal, but it's a good way to start. And then software links, including my GitHub, and then fork projects. So I forked some projects as well and modified them. And then, well, this is a slide you can look at. Someone asked about debugging less, and what's the strategy with such a giant system with so many subsystems, and how do you debug something like that? Which, yeah, when someone asks that, you're like, yeah, it sounds really painful. But I tend to, all these mini projects, I tend to do mini projects on SULB, but kind of like we used to do for robot contests or something, or like just go make your Arduino turn a LED light on, so, or make it turn in a circle or something. So every project I do on Orange is a single feature at a time as a sub-project, and so I only work on that one thing. I get the sample code working first, then adapt it to the system. And I'll use the Arduino Uno with the new sensor, get it all working there with the sample code before even thinking about trying to integrate it into Orange. And that goes for every little piece of hardware that is on here. I tried it somewhere else first, on an Arduino generally. Then, yeah, write new modular functions as you plan to use them. So I'll write a new piece of code. Once I did that initial test with the sample code, then I start writing a new piece of code that's going to be roughly the way I want it to function. And then you write a small test program for each function you add, including edge cases. Now's the best time to find those. And then important, add error checks and return informative errors. Always find a way to print out debugging text somewhere visible from any code, even over a serial port. So debugging via text is extremely important. I don't know, maybe people already know these things. But for those who are more hardware oriented, this may be helpful information. And then, yeah, write your print statements wherever. Be liberal with them. You want to know what's going on at all times, and assume there's going to be errors in your code. And when you print out the information, you'll see the error so much quicker. Source code debugging is very difficult or impossible with these embedded systems. Putting breakpoints. I've never even bothered on an Arduino getting the doctor whatever wizard thing to do Arduino source code debugging. On something like this, you can debug. Well, debugging Python is you could do that, but I never put breakpoints on Python. The thing is, it's also a real-time system, so it's hard to debug. You stop it, it's like you've already lost the context of what's going on. And then you disable the prints once you verify, so you don't have a million printouts. And then always add a new test function. So, and then for new hardware, I think I already said this. Wire up the sensor to the simplest hardware you have, like an Uno or a laptop. Get the sample code working, rewrite code for integration based on what you've learned. So you can look at this. So thanks and credits, Dr. Bruce Weimer, for introducing us all to Slam Tech and the RSS and AI SIG. And the Python main code, he did give me his Python main code, one of his earlier ones. It saves you so much time when you can share code. Gary, Slam Tech DLL, Alex, IIR Embedded Workbench. That's the software. You can download a free version of that with a limited K. You had two choices. You either had to buy it, or you could either have a limited K or limited time. But since my whole system here is under the maximum, memory, I just said I'll take the memory version and then have it forever. So, for at least for this STM32 STP Mini, it will never require me to buy it. And John, who's here, Scott Horton, Brian, who's also here, and the social distancers, that was a great motivation. Everyone else. So thank you. That's the end of that. All right.
All right, so since we skipped lunch, do you want to do a quick business meeting with the treasurer? Can you give us a quick report?
Yes, there is no changes from last time. Balance is $1,025.93.
Well, thank you.
1,000. Okay. I just got an email that the PayPal isn't working. We haven't heard anything yet. The PayPal ability to send money to the club is not working, or someone's having problems. Is Catherine highlight me? Oh, I can unhighlight me.
Oh.
How come it's still me? I turned it off.
Because it's on speaker view mode thingy, or is he highlighting?
Here, I fix.
Oh, because.
There we go. Okay, so last month I gave you a quick sketch of how to make use of my worthless tiny palm phone to do something cool with robotics. And I was fully prepared to give a 10-minute talk about how you can leverage existing models and Fusion 360 to get from point A to point B. And Fusion has decided to schedule their maintenance window this morning. The maintenance window was supposed to end at 12 o'clock, and it is still down as of right now, +8, -8 hours. I watched it go from 12 to 1:30, and they're like, maybe it'll be up by 2:30. So I'm gonna wing it a little bit. So luckily their online thing is still open, and so the first step was like, okay, download a model of the phone and take a model of the servos and just kind of fit everything together to see if what's going through my head is actually physically possible, right? And I'm like, okay, well, it did. And hand waving here, there were 4 different proof of concepts where I modeled what the hinge might look like and then the interconnects. And anyways, a whole bunch of OCD and many hours spent later. I've got a completed model where all of the parts are designed to be 3D printed. It's testing the limits of my FDM 3D printer with a 0.4 nozzle. But it all,
because
the parts are super small.
Super small.
So I've got a bin of parts that I'll pass around here that kind of shows how I've gone so far. I did a test print of the arm, and in the fit test, everything fits together. It is a royal pain in the tuchus to assemble. I didn't design it to make it easy to make. I designed it to be as small as possible, and yay, I won, but at what cost? The parts are, the servos are heavily modified. And they fit into these 3D printed shells. And so this is as small as I can make a working servo joint using this printer. It's funny, it's like, you look at the parts, you're like, wow, those parts look really good. But then when you zoom in with PETG, you're like, what are you printing with, garbage? They actually turned out really well. The servos that I'm using as a base are very robust and resilient. You can back drive these things all day and abuse them all you want. So they make a great foundation, and everything that I'm learning here, I can now kind of backdate to other projects that I was working on and dropped that needed small servos. Everything just works.
What were these, sir? These are
K98958s. They're a little bit shorter and a little bit wider than the MG90s.
Yeah, that's the standard ones, right? The 9 gram.
Yeah.
So these are smaller.
Yeah. So
better, much better.
They've been great. Metal Gear servos, you can get them for like $5 shipped from AliExpress. I ordered 60 of them. Because why build one robot when you can build 2 at twice the price?
You have to wait.
I also decided I wanted to use 1.25 millimeter headers, and I found these amazing silicone 4-conductor 30 gauge ribbon cables that, like, aesthetically go perfect. However, here's a circle of hell I put myself in. Each one of these pins, because I'm like, I'll just order them from DigiKey, and that was pricey. And so you have to get a special crimper, and then you have to use tweezers to put each one of these little things into the crimper, and then to trim the 30 gauge wire to stick them in to create this. And for those of you in the audience who are paying attention, 2 things you notice are different. First off, 4 pins, servos only require 3. Well, if I'm going overkill, I might as well take a 4th lead out to report back the servo position. However poorly it is, it's still something. Also notice that it's a 5-conductor cable. I ordered the wrong ones. So I knew I wanted 4-pin connectors. I thought for sure I had ordered 4-pin connectors, the male and the female matching pairs. I did not. They're all 5 conductors, and so I'll have to order different ones. Wow. But I have a test cable in there. It works. I learned enough Flutter to code in a quick proof of concept for the face with eyes that blink. And so that part works really well. Here I'm holding up the 3D printed arm to the back just to see what it looks like. The whole effect looks great. I've been super pleased so far. Once I get it assembled, everything fits really well and just works.
How did you do the eyes? Is that?
I learned just enough Android development using Flutter to be dangerous.
Flutter.
Yeah.
Is that a small phone?
Yeah, that's, so it's in the bin.
Yeah, it's a baby phone.
It's
Where
a
do you get a
failed
small phone?
companion device from 4 years ago that was sold as a Verizon exclusive. And poor battery life, slow processor for the time, and expensive. So you can pick them up for like $70 used on eBay right now.
Oh.
And it's funny what sparks inspiration. And that was one of it. So the ARM's being passed around. I think this is a video clip. Proof of concept, a fit test. All the parts are 3D printed. Everything fits together. And once it's fit together, it works. I'm using bearings this time instead of just plastic on plastic. So in theory, once it's assembled, unless it's dropped or catches fire, it should last a long time. So it hooks into the top horn on top, and on the back, it's got a 8x5 by 2.5 millimeter thick bearing. You can go down to 2 millimeters if you forego the seals on the top and bottom of the bearing surface. So I thought I'd splurge with the extra 500 microns. And so that's kind of where I'm at. In the bin, I've got an example battery that I think will fit really well. I have, it turns out 1.25 millimeter 4-conductor pin and wire assemblies are available in the LED aftermarket. They're mass produced for cheap, but they use 28 gauge wire. So I ordered a bunch of those to see if maybe I can use something that doesn't require me to crimp with tweezers for the next 6 months. The other thing that came up was I'm kind of pushing the limits with 3D printing. I think it looks great. It's super shiny, PETG super resilient, and I really need to complete the proof of concept using the tools that I have. But I've been thinking in the back of my head that this might be the opportunity for me to dabble in resin printers. There's some tough ABS-like resins out there, and these parts are designed around FDM 3D printing. But to go back to the drawing board, with a resin printer, I would be able to completely recreate the servo casing and integrate it into the joint, where right now you disassemble the servo and then you Dremel out to curve out the edges and reassemble the servo, and then the carcass of the servo goes into my 3D printed case. I could make it even smaller and even better if I just did the whole thing, which you can do with the accuracy and detail available from a resin printer. So I'm on the fence about it, which means I'm probably going to do it because, you know, why finish something when you can do the first parts over and over again? When all goes according to plan, the 24 connectors take up about this much space. In the current design, I'm hoping I can get away with a 1 amp hour battery. So that's what's currently being modeled. I ordered a couple of Raspberry Pi Picos because I'm thinking I'm going to design a carrier board using the Pi Pico chip, and I need a couple of buck-down converters, and I found some commonly available ADC I2C chips to be able to handle the analog-to-digital conversion. And with JLB PCB or PCB Way, I can get a couple of manufactured to cut down on size because there's not a lot of space to go around. So that's the current game plan. The thing plugs into the USB onto the phone. The phone won't provide power, but by being clever, I think I can provide power using the battery to both the phone and the Pi Pico. There is a ROS Flutter Dart library, so I can write an Android app that speaks ROS. It's ROS 1, so you need, if you're using ROS 2, if you're going for punishment on the other end, then you can use the ROS bridge for that. But so far, what gets me excited about this, other than doodling things that I may or may not ever finish making, is that the Android phone, even this $70 throwaway phone from 3 years ago, it's an 8-core processor that maxes out at 1.4 gigahertz. It has 3 gigabytes of RAM. It has a microphone, speaker, camera, display, touchscreen. You have access to everything in the Android library. There's Android SDK modules for speech to text, text to speech. Like you have access to all of this in a $70 device. And just by a hacked USB-C cable together with the Pico, you can control the servos, collect status back, calculate out command and perceived position, velocity, acceleration. You can code into the Pico to do things like, okay, once you have your ADC values mapped so that you know what the command position looks like from the potentiometer output as well as from the black box controller on the inside, if you've commanded it to a position in over X amount of time, if it hasn't approached that condition, that means that you're in an over torque, you're over commanding thing. You can catch that in the Pico and turn off the servo and report back. Like, so that just having access, even though it's not totally accurate, having access to that ADC position pin opens up all kinds of opportunities for additional data as well as some safety things. Now, if I can get it to fit all into a backpack on the back, then great. But so that's kind of where I'm at with this. It's been a lot of fun, and I'm looking forward to seeing what direction I go with it next. So hopefully, in a couple of weeks, I'll focus enough to get the legs printed out and assembled. The only thing I'm unsure about is I don't know that the servos have enough torque to run the legs with everything assembled. That's the only unknown really for me. Everything else just works, aside from designing the carrier board. But yeah, hopefully I'll have more of it done, and I may or may not have resin printed parts to show off next month. We'll see.
If anything, you can redesign the bottom and put little wheels on it.
Wheels? Why have wheels when you have legs?
Extra servos. I mean, that's gonna be a lot of weight on.
Yeah. So yeah, that's the only part that might not work out well, but you know, you don't know until you try.
You just have huge legs.
Oh, right, with the larger servo size. Yeah.
And is the Pico for Pico plugs into the phone via USB? Is that?
Yep.
And then from the Pico is really in control of the servos and
yeah. So that because
that's running Python or MicroPython.
Or no, probably just C.
Just C.
Yeah. So I'm not using ROS on that side, and it has more than enough programmable timers to be able to run 24 servos at once. There's enough pins to be able to run 24 servos, and there's just enough pins for me to do all of that, and have the pins for USB connectivity, and then two I2C pins to communicate with the ADC chip that I found that GW something PCB has and stuff.
What is that one?
They do low cost PCB manufacture and assembly.
Right. No, I mean, what's the ADC?
Oh, I don't remember off the top of my head.
What are you using it for? I mean,
to read the fourth pin.
Oh, that's to read the fourth pin. Okay,
to get a rough idea of the position.
So and then how do you from the phone to issue commands? That's over to the to get commands down to the Pico. Is that through just serial? Serial port?
Yeah, probably much like because I developed this for InMove originally, so I've done it once or twice already. Is develop a quick and dirty serial protocol for communication between the Pico and there. I'm assuming that there is a USB serial port available in Android for the phone, right? So assuming that that's there, which I haven't verified yet, then yeah, it's just a matter of passing packets back and forth, and then from the phone forward, it's whatever I want.
Right, because then it would go across you plug in the phone is a USB, so it plugs that, and that goes in, but not power, won't power, you're not drawing power off it.
Yeah, I'll have to power both devices
separately.
Buck down from.
Well, the phone has the phone has its own battery, right?
It does,
it's
yeah.
Limited.
It has an 800 milliamp hour battery that's 3 years old.
It's not very,
So might as well, through the backpack, just power both devices, and then it can charge while it's there. So I'm also not sure how much power all of these there's enough stiction in the servos that it can hold its position without a lot of power.
Huh.
So I might be able to get away with using that battery, but I'm gonna design a secondary backpack around the 635. I found some nice cells with a micro USB charger plug in it. So integrated BMS, charge using USB, so just stick them in and forget about it. So I'll see if I can come up with a different backpack design. And that's gonna have almost 3 times the power potential, so this thing could run around for a couple of hours with that.
Oh, it wouldn't be instead of a battery pack like.
Yeah, instead of this battery pack, yeah, it would be a larger battery pack.
Larger, oh, but you found it. Yeah. You'll have to, I guess you're obviously dealing with the balance of the object, of the whole thing.
Yeah,
with
that's
the,
what I was
the
thinking.
backpack and
Yep.
having it stand up, is
Yeah,
pain.
Oh, yeah, that's why I'm putting the weight high in the
Yeah,
back, or like,
high.
counterintuitive, like, put it low so you don't fall over. Well, I got an IMU. So I'm wondering, without having like direct fine grain control over the servos, how much I can get away with for balancing and path and motion correction based on that. I'm not sure, maybe not.
Well, this is a voyage of discovery.
Yeah, exactly.
You don't know what's gonna happen.
Also, bigger battery, more weight,
It
and
looks
more stress
cool.
on the joints at the bottom.
But you've got 24, it's 24 little servos, because it's like, what is it, 4 in each leg?
Yeah, here, let me see if I can.
That's a lot. Is that more than the biddle? That's more than the biddle. Biddle is what? 9 or
1, 2,
12. I don't think I can turn off the backpack. I don't know if I can turn off the view from here, but
look at all those connectors.
yeah, it's gonna be a monster. Well, it's only 6 inches high, but and anyway, we'll see how far I get, and I'll keep you guys posted, and this will be the basis of whatever I'm going to talk about next month.
Nice.
Cool.
Thank you, Alan.
All right, thanks.
That's nice. Jim,
You guys see
next?
Yeah. All right.
That can be last, so just give a little.
Or do you want to give yours?
Okay, I mean, mine is just a little tiny fiddle. So like he was showing, it does have an IMU on it where he can detect his orientation.
Oh, yeah.
So he knows when he's upside down.
Maybe get up. It's the same as the one it's pretty much the same behavior as what his latest version.
He provides a lot of sample code, and you can just like put them all together. The remote has a bunch of different functionality.
Hey, Murphy's Law, he's gonna flip the
A
trigger.
little roll that he does.
You don't want to.
Roll over.
Man, not off the table.
You need a cliff sensor on that puppy.
Yeah.
No.
Yeah, he does that because
it's slippery. This is a little bit too slippery, right?
it might be. He does have.
Will we work on
It
that?
does have some little rubber.
Can you put rubber? Oh, I was gonna say,
It
can you
does come
add
with them,
more
I just-
rubber?
I just never put them on.
Oh,
Ah,
okay.
I do have them though. I don't have the 5-volt board that he shows with all the other integrated stuff. This is the original one.
At Mega.
Yeah. So it's kind of like you said, it's a little limited in what you can do with it. But
Wait, the one with all the connections, wasn't that also at Mega too, or is that
it does. This one.
It's just a different board.
Let me turn it off, so
There's a whole series of how the thing
It does
evolved,
have,
right?
it has a lot of connections for like extra stuff.
Yeah, it's got those multiple sockets.
Yeah,
right?
it does. It has a whole row.
Yeah, that's the one with the row. He
Yeah.
was saying, in fact, the newer one with the plastic servos and the
It's less.
new, that doesn't have this
You're
much
right.
expandability, which is counter. You almost want to buy the more expensive older one if you want that expandability.
Well, he did say you can always solder your own wires.
Yeah,
You can still do it.
But it's still limited.
But then you
because
might want the metal gears too.
Yeah,
Yeah.
it's cost saving. That's what it is.
Yeah, see, they're going for a business, they're doing exactly the right thing. They're
Mhm.
making you know, a newer model that's cheaper, but is not quite as expandable.
And you saw the Cadillac, like his proof of concept.
So that was
his
the
dream
Cadillac.
was the starting point. And it's just so amazing. But like designing something that's cool and then manufacturable at a price point is, it's.
That's why I don't do this as a business.
Anyways, that's Biddle.
That's cool. I might want to have to get one, even though I bought that, you know, a couple months ago. People were all buying this this robot dog online for $100. It was only $150 or something, and I haven't put it together yet. But people on the homebrew robotics have been. This guy Mark Johnston, he's built it and he's shown videos, and it's kind of like Biddle, but Biddle is much more easy to build, I think.
Oh, the building he said that 30 minutes. That's very.
That's aggressive, probably.
No, that's an overestimate. I mean, all the pieces pretty much just locked together. I would say 15 minutes.
Oh, so it's really easy. Yeah.
It's really easy.
Okay, yeah. Versus the one I bought is like many hours of putting together small pieces.
No, I mean the frame is all one piece. You just kind of snap pieces onto it. The toughest part is because each leg has these little. Has these little springs to kind of like protect it in cases of shock or whatever. And that's probably the hardest part is putting those springs in there.
Yeah. But yeah, it's a great product. It's now that the more you see it, the more you want one. All right.
All right. Thanks.
Thank you. All right. So I have my other project that I've been doing lately, which I showed last month, I believe, was the metahuman stuff. And let's go to the screen here. So I've been working on that quite a bit, and here's the video. So I did publish this video already, but let's make sure I get those buttons on. So Dr. Bruce, I'm sort of collaborating with him, and he kind of wanted this add a feature to his chatbot, his desktop chatbot, and to have a human be able to speak and with lip sync, metahuman, like this. So let you check this interaction out.
Hi, I am Cooper. I am an artificial human ready to chat with you. I have a background in software engineering and robotics.
Hi Cooper, how are you?
Full of scintillating repartee.
It's a little slow.
Great.
I'm really interested in chatting and learning with you.
Well, I have a robotics question for you.
That's fine. I would like to help you any way I can.
Can you recommend any starter robotic arm kits?
That is a tough one. If we go by the price and size, I think the beginner's iRobot Create to Learn Drawing 44 Robot $100 4 inches would be the best bet.
Where did you get that?
Where did that come from?
I don't know. By the way, just to let everybody know, this is using GPT-3. I did not script this in any way. It's all on the fly. I don't know what it's going to say.
That's great.
And I guess I should give the background. this is a compilation of multiple things all inside Unreal Engine, including, well, I could go through the, I'll show you a brief diagram, but it's taking from the microphone into Unreal 3. It's doing speech to text using BOSS locally on whatever. This is just a video, but and then it takes the text, sends it to GPT-3 through a plugin. And all the stuff is in Unreal Blueprint, which is sort of block programming and plugins. And then so I'm sorry, sends the text to GPT-3. GPT-3 sends back a response, and it's structured the same way Alan has always been doing it, with the human bot or whatever, and the history of everything you've said gets sent up. And yes, it's using a paid account. I'm using my $18 whatever of free GPT-3 with DaVinci in this case. And so then the GPT-3 sends down a text response. Then I send that text response to a Google text-to-speech, because I need the audio actually. So the audio then, and that could be done locally too. I mean, all this stuff could probably be done, most of it could be done locally eventually, but then I get back speech in the form of audio. That gets sent up to another cloud service for lip sync animation from a plugin company that's MetaHuman SDK. Then the lip sync animation comes down, and it's coming down in chunks to make this thing more responsive. So if they think it's slow, it was even worse before. I'll show you. So that comes down in chunks, animates the lips, and then plays the sound as well. So all that stuff. You can finish this one.
I do. Artwork, Corby Cooper, paper theater for the humans in the mechanical age, Siniferous.
That was a random response. I don't know.
I mean, do you use the Arduino microcontroller?
I do not use a microcontroller. My design does not require one. I run on two types of processors. One is my main processor, which is significantly less powerful than a microprocessor, and the other being my processing chips. They perform low level.
I kind of cut it off, so.
But back to the robotic arm, how does it work?
I act on the arm using tiny 4.5 volt currents through 4 wires. I sense my position by monitoring the resistances in the wires using electrical signals flowing through them, and calculate what to do next by processing those values through a set of mathematical.
I'm cutting it off
that's
as far as the talk. I don't know if that's a sensical response or not, but.
Thanks, human. What would you like to talk about?
His stare is kind of intimidating.
Well, that's
yeah, now.
Have a good night.
This is a work in progress as far as that goes.
I hope we are able to chat again.
Anyway, it's getting there. This one was blinking before, and it's right now it's not blinking. Or I think as I'm using that streaming. Because here, I'll show you the second one.
Morning, everyone. Welcome.
The one why did it do that? I didn't even ask it to.
Full of scintillating.
So, this is using a cloud service to do the animation. And so I'm at their development process can actually animate the eyes as well, and the neck. There's a hook in for some degree of facial, a couple things, but the eyes mainly. So the eyes will normally blink, but I guess for the streaming, the upgrade, they're not working yet for this streaming animation. It's like the problem was if you just send a whole sentence and then wait for all the animation to come down, it takes too long. So they would allow you, they made a streaming system so that it would send down the animation in chunks. But that one doesn't do eye blinking. But I noticed this one, this is now, this is an integration of body animation and lip sync animation. Believe me, I'm struggling as a beginner with Unreal Engine, but this blends some. I found an idle animation from another example, and I found a proper way to at least blend the lip sync. But I'm such a novice. This doesn't work except for one response. Otherwise, the lips stop moving. But this is what I've achieved so far.
Hi, Kyoko. What do you think of the future of AI?
So this will take even longer. But this is an animation idle.
I think AI will be more and more important in the future. Maybe someday AI will be better than human. We may depend on AI in many ways. Even now, people can't live without smartphones. Someday we may depend.
And I probably cut it off, from 50 tokens or something. I'm not sure how you get a full response.
I have 8 levels of detail.
Sorry. A full response that is limited but ends properly on a sentence.
Depending on the API, there's sometimes an option to end at the first punctuation or period. Otherwise, you grab sets of tokens and then you manually set them together. And after you find your first period, then you just stop recording after that. That seems to be the 2 ways that work for me. It depends on the API.
Yeah, see, I tried to find the first, that's the way I coded it in Unreal was just the first period, that's too early. So I need to put in more sophistication. Right now I'm not using that period. I just said 20 tokens. But I'm like, how many tokens do I need and when is it gonna? Now it's supposed to, well, this is more detail, but they say it can automatically stop at the next prompt because it'll include a human prompt in its output. Because this is all done with those prompts like human and then Kyoko or whatever, human Kyoko, and I have it automatically stop at the next time it prints out human or Kyoko colon. So that sometimes is in the response, but that doesn't completely work. But to show you, kind of a little bit inside of that, how do I get back? Let's see. Let me go back to the screen, and then this. So okay, here we go. So this is kind of what one of the this is what blueprints look like inside Unreal Engine, and what I had to put together to. This is just the part that is handling. This part handles the it's connecting to this VOSC server and handling the local speech to text that's when you're just talking. So that part was using a plugin, and but the main core code is this, which it didn't even fit on the screen, but each of these modules I've kind of put them together. And I have this also. I'm connected to my computer at home. I can show you, but like this section is for playback at the beginning when he introduces himself. That's easy to do. And then capturing the voice is another section, your voice, and then sending it to the GPT chatbot is this, this section. And then there's another text-to-speech section, and then audio to lip sync, and then off the screen here at the end is it finishes playing that, and then re-enables the microphone. You have to disable the microphone, of course, while the bot is talking, or else you'll get very interesting, we call it AI feedback or something, where it starts talking to itself, and it starts answering. You're like, oh no, what's going on here? because it'll start talking to itself. And I think that could be a whole other project to see what happens when you have the bot talk to itself. But yeah, this is my home computer, and this is the environment of an actual Unreal editor. And here is the chatbot. Okay, this is an actual live view of these the level blueprint. So it's an interesting way to program. It's in some ways hard, in some ways quicker, especially if someone gives you, like for a lot of these, I was given a picture of what it's supposed to look like, and I just had to figure out how to make it. Ideally, you can actually share one of these blueprints easily. There's a website where you can just copy and paste it. And so I'm like, oh, why didn't they use that? Because I ended up manually making all this. And you're like, well, but then you do learn it. It's kind of like coding by example, where you actually type, when someone types the code and then you type it, you definitely learn it better than just copying the whole thing. But it can be frustrating too, because you're like, well, how do I make this node and connect it? And it's not working. And so there's a whole learning curve to this Unreal. But it's essentially a program in Blocky, but it's kind of a Blocky for adults. So yeah, that's where I'm at with that. Dr. Bruce wants to incorporate it. I've kind of put it on hold right now. I mean, that I've achieved what I set out to achieve, which is a basic thing. As soon as the eyes are blinking properly, then I'll really be more satisfied. That idle animation is, so that's the eye animation can come down from that lip sync, but the body animation, that's just an idle loop. That's a separate thing. So but it's an interesting kind of virtual robot is what it is, right? That's sort of why it's, I think, relevant here. But anyway, so I'll probably publish all this whole blueprint, and so people can save themselves all the time and paste this in, and you could have your own, chatbot companion. And hopefully it does some more fine tuning to make the responses. Oh, I didn't show you the part where it deals with the part that it deals with GPT-3, you can actually configure that text and the prompt essentially. So that's kind of cool. So you can make him into whatever kind of chatbot you want, and and I could even expose that to the GUI. So here, this is what it looks like here. Can I zoom in? I guess that won't zoom in bigger, but so this is the GPTs. This has your prompt here. The following is a conversation with Cooper, a type of artificial human, blah, blah, blah. Human, hello, who are you? That kind of thing. So this is the initial prompt. And then, so you can put whatever you want here. And then you can use DaVinci or other engines that are available, and you can set the maximum. So this is the sort of interface to how it works in the plugin to GPT-3. But in any case, yeah, if I get it so that the eyes kind of, if the body moves and the eyes blink, it'll be a real chatbot, something that you can look at without the uncanny valley, and because the non-blinking thing is like a non-starter for
staring through your soul.
Yeah, but again, this is an engineering proof, so I apologize.
No, it's great. And the delay, it's like he's staring at you and formulating, and then processing. And when yours came back, I'm going to kill you now. I was waiting for him to say that.
Right? That's the look on his face.
Yeah. Well, that would have been that would have been something, huh? But yeah. So yeah, that's that, and it's interesting. It does perform better than what you saw because there's a delay. even from my laptop, obviously. The smoothness is pretty good on a good computer, and that's another issue, is it does take some horsepower for that animation. Like, it won't run on my laptop. That was a video recorded from my desktop with like a 2070, an NVIDIA, not an extremely expensive graphics card. It should be something that a normal video game would use, a reasonable, current, up-to-date video game would require. Thank you.
Thank you, Jim.
All right, thanks, Jim.
Okay, anybody else have anything else? If not, I guess we can wrap it up and see you guys next month for a pizza party.
Pizza party.
Yeah.
More pizza for us, but maybe that will get more people show up.
Yeah.